Okay, good morning all. Can you all hear me?
Yes, sir.
Yes.
Okay, welcome to the fourth day of this FDP, and I'm sure that you might have enjoyed this 3 days, and then the rest of the 2 days as well. We're going to enjoy the learning. And today we start with Mr. Mohit, and the topic is about point cloud introduction and case study, because we are talking about point cloud, we are talking about LiDAR, we are talking about 3D laser scanner. So these are all some of the terminologies which we use again and again. And what is its prospects and what is the fundamental behind this particular technology? So that is going to be explained by Mr. Mohit Bhautiyal. He is a graduate from Maharshi Dayanand University. He did his BTech mechanical engineering with the designing from 2009 to 2013. And he has, after that, he has worked in many firms. I mean, I would name some of them: graduate technical intern in Bharat Electronics and a technical trainer in CETPA Infotech Private Limited, and then uh, he's a Shotham Instrument. He is with Shotham Instruments as a senior engineer for scanning and mind mapping solutions. And then he's also a senior engineer for LiDAR and aerial photogrammetry of PEGS, Plant Engineering Geomatics Services Private Limited. And also now he is working with Faro Technologies for the past 2 years, 6 months, if I'm not wrong, as a technical sales engineer and a field application engineer for AEC and PSA. Yeah, and he has got 5+ years of experience in sales, business development of the engineering services and products, primarily in the field of mining and surveying sector. And Mohit is associated with us, by supplying us Faro LiDAR Focus 350 scanner and its allied tools, and we are working closely with them. And I'm happy to welcome Mohit here for today's event, and I'm sure that his experiences will add value to this FDP. And I request all the participants to please be attentive, and then you can get maximum out of today's session. And just housekeeping steps. I mean, please mute your mics, and in case if you want to have any questions and clarification, please lodge it until the end. In case, Mohit, this is for you. If you feel that somebody is disturbing, like, I mean, somebody's mics are on, then you have got an option of mute all. You mute all and then unmute yourself when you start continuing your program. And attendance will be through a poll, and we will inform the speaker before we take the attendance, and it can be any time during the presentation. Yeah, thank you so much, and the room is yours, Mohit. Please go ahead. I welcome you once again.
Yeah. Thank you, sir. And good morning, everybody. It's good to see, sir. Means to be back on the platform with IIT Palakkad.
Yeah.
Remember last time when I visited over your campus, so we had gone for that complete training and all. So once again, sir, thank you from my side and from the behalf of Ferro Technologies. And we would be happy to share the platform in regards of the sharing the knowledge about the laser scanning, point cloud. And I think during our after my session, I'll also go through like one of the case study which we have done in the field of construction or with the real estate companies in India itself. So I think what I will do, sir, means I'll quickly start sharing my screen.
Yeah. Thank you. Please continue. Yeah.
So I hope like everybody can see my screen.
Yes, sir. All.
Okay. Yeah. So I'll just hide this options again. Yes. So as I mentioned, like good morning and to everybody. And my name is Mohit, and I'm working as a field application engineer in Ferro Business Technology. Currently, I look after for all the technical solutions offering or to prepare the complete solution for the people from architecture, engineering, and construction, as well as from public safety. So I look after for the complete construction field as of now for all the technical requirement, and as well as for the police department, where we work closely with the public safety, crime scene investigators, and other people to document their spaces by the help of our laser scanning system. So if you have any question, any queries, as Senthil sir said, so we can try to answer in between. You can put it in chat, and maybe I can go through during the session, or at the end of the session, we will have a Q&A session or a round. So I would like to answer all of your questions, queries, or any suggestions if you guys have related to the session, technologies, any related to any of the product. So let us know, and I'll try to answer those during the end of the session itself. If I start about ourselves, so basically we as a Ferro Technology, we are in the field of 3D measurement, imaging, and realization technologies, and we have been in the market for more than 4 decades now. So if I say like our last 40 years experience, so we have been the people who have been solely responsible in the field of the development of laser scanners. So we have been developing laser scanners, from the small laser scanners, which may be used for the dental scanning or for the medical industry. And we have been developing the systems which can actually do the scanning of a large building, or maybe of an entire airplane as well. So currently during our journey itself, so we have been making this technology more convenient to the users from the industry, and to be more convenient for the people, such as from the research organization like IIT Palakkad, where this technology can be used as a part of their curriculum, and it can help the students to update or to get an idea about what exactly is going on in the industry right now, and what sort of application, what sort of requirements industry is having, whether it's in the field of progressive construction monitoring, it can be in the field of scan to BIM conversion, or scan to building information modeling requirements, or any other similar aspects which we do have. So if I talk about ourselves, so we have our main headquarters in Lake Mary, Florida. So we are basically a US-based company, and we do have our worldwide presence in most of the countries. Currently, we do have near about 25 offices in 25 countries all across the worldwide. And in India, we have our office in New Delhi. So right now I'm based in New Delhi. So we have our head office in New Delhi, and then we do have sales office in Pune and Chennai as well to support locally. So most of the time, I think if any questions, any technical requirements you guys do have, or any sort of like queries you guys are having, so you can get in touch with me, and I can assist you on all your needs and requirements. If I talk about the major challenges which whom we are serving, or what are the challenges which our customers are facing right now. So we have actually segregated the entire industry in 3 disciplines as of now. So currently we are solely looking after for the 3D metrology needs and requirements, where we do have the scanning system, which are like the high-end one, which can give you an accuracy in micron levels. And those devices can be used to identify the quality issues during your production itself. Not only that, means if any during the production itself, like let's say you want to fabricate maybe a door or a window, or maybe a prefabricated construction needs to be done, and you want to do the project the layouts or cutouts for the windows and for the door placement in a prefabricated facility. So then we do have the 3D laser scanning, or even the 3D projection system, where a 3D projector can keep on projecting the lines, the CAD lines or the CAD geometry on the top of your element with the real-time scaling. And the person who's doing the job, means whether he's making a cut or maybe he's doing a welding joints and everything, he can use those laser lines or the guidelines which has been projected by 3D projector on the top of the surface as a guide rail. So as a result, the guesswork kind of thing, like marking out with the chalks, making the layouts, the rough calculation and everything has been eliminated. So we have been fulfilling these sort of requirement for currently for the metrology industries. Apart from that, we are also working with the AEC professionals, and that's what I am responsible for. So to build up any sort of technical solution, so I'm the one who do that. So currently in the construction means preventing the construction cost error, like you may have seen, and in fact during my slides itself, I'll go through some of the challenges, the common challenges which were there in the construction industry. So the cost of rework. At the same time, when we say the delays in the project timeline can also increase the cost of the complete project itself. So all those factors can lead us to, for delaying or for passing the deadlines of our project. As a result, we are providing these laser scanning system, which can help them to digitally, capture the entire site information within a short period of time or at a faster speed than the conventional or the traditional technology. And later on, then you can bring all that data, all that digitized information into some software platform where you can take out, let's say, the as-built model. If you want to go for a simple comparison, so you can also compare between two different scan data together. So that if tomorrow you say like, I want to see the deviation on a bridge at a certain time period. So we can do that. We can scan the bridge at one time, then we can scan it maybe, let's say, after 6 months or a year. And if there is any deviation or deflection on the surfaces of the beams or on the bridge, we can actually detect it by the help of laser scanning system. Not only that, I think right now this technology is being more popular and growing day by day. In fact, the BIM adoption curve in India has been increased substantially from last couple of years. So I think during this entire platform, we have lots of speakers who talked about the BIM and other platforms. So you may have seen that, this BIM is keep on growing. Now, to extract a BIM information or to extract an exact information from the site, we have been providing these scientific instruments or the measurement devices, which can be convenient for the users to capture or to document the site information accordingly. Lastly, but not the least, as I mentioned, so we also have public safety. So we have a complete team dedicatedly for the public safety and CSI requirement, where we actually do the documentation of crime scene. And that documentation can be used as a courtroom presentation. So if tomorrow something happened, let's take an example of a car accident, if something happened. So what is the exact viewpoint, from the crime scene? Instead of physically going to the site, you can actually do the complete virtual site tour. And you can have, let's say, maybe a victim, means if a guy has been hit by a car. So you can actually have a projection from the victim point of view. And you, at the same time, you can also evaluate between the other viewpoint from the driver perspective with the person. So we actually do these sort of like the complete the courtroom presentations and everything by the help of our systems. And all these data which has been captured by the Faro devices, they all have been actually been accepted by most of the courts in the worldwide. When we talk about the code validation part, so the good part is that the Faro device, the Faro laser scanners do have the encryption, so that whenever you digitize that information from the site, that information is going to be safely secured and has been encrypted by a hash code or by some hash value. So whether it's needed by a construction company, whether it's needed by a public safety or police department, whether it's needed by maybe needed for the metrology people. So whatever you document, it actually get encrypted by the help of the hash value, which has been applied or implemented at the time of laser scanning on the site itself by the help of your device. So the good part is that, like tomorrow, if somebody try to tamper your data or maybe try to manipulate the data, that can be easily checked and can be verified during while evaluating the data inside your scene software. So I'll go through one by one all these things, I think, during my presentation, and if time allows, so I may also show you some real examples from the site which we have been capturing and where we have used our technology for the construction industry. So if I talk about, I think, if we quickly start. So when we talk about the challenges which we are facing from the AEC prospect, or being as a civil engineer, or maybe an architecture or some other engineering discipline professional. So I think the largest or the biggest challenges which nowadays are coming is, the large size of the project. The projects have been keep on growing, like the sites where usually we used to work in the old days. Now they have been growing exponentially, like at a very vast scale. Not only that, the time constraint is like another challenge. So if there is a construction project right now going on, then definitely there will be some time boundation. But nowadays, the lesser the time you take, more you get the profits, and more you get the market awareness about your company and about your work itself. So apart from not only the large or the complex sites, we also have time challenges nowadays. Not only that, the complexity of the site, like we are living in such a populated environment, or in a society where we do have lots of movement. The crowd movements could be there. So take an example, like, if tomorrow you want to scan a railway station and you have the people movement all the time, then you actually get a very short window for doing the survey work at your site. Probably you may be doing the survey work at, it could be possible like in some uneven times, okay, like maybe in the daytime. If it's a complete crowded, maybe you were trying to do it in the nighttime, or the time when the traffic is slow in that particular area. So it may lead you to the uneven time areas, or uncomfortable time zones to work, depending on your site. Not only that, as I mentioned, the complexity of the site. So usually, like, we do have a simple building in the old times, but nowadays you can see that the complex air conditioning system could be there. There can be a water filtration plant. Let's take an example of an airport itself. So there could be a terminal building. There could be like the complex HVAC or ducting is going on all around the area. So the complexity of the site is also getting becoming much more challenging in the upcoming events, or during the current construction industry. The cost of I would say the construction waste, that is one of the big challenge. And in fact, like we have seen, like in most of the cases, for the fluctuation of the cost, like 30% of the cost increment of a project is mainly or solely responsible because of the cost of because of the construction waste. We have seen some areas like where the inventory has not been done correctly, and as a result, like the most of the material has been piled up on the site, and it can be increase the construction waste because you don't have any proper documentation of the site. And whenever you need any element or any object from that area, you may be like chasing around all around the places, like, okay, where is that part, or where is that component? It can be a beam, it can be maybe some other structural elements or some other features which may not be correctly inventory, or which may not be recorded correctly in the initial time. Then we do have the rework. And when we say the rework, I think this is one of the challenge. Once you do the construction, if you compare it with the traditional or the conventional method, we used to do the initial survey by tape measurements, or by having some raw or sketchy drawings of the site. And then based on that, or based on those measurements, we used to convert it into a 3D model. Now, the challenge is, like, when we do the construction on the site, or maybe the contractor who's doing the construction part, and the people who are from the design team and the site owner, these three guys are different identity. Now, these three may not have a mutual understanding, or maybe a mutual collaboration on such a level that tomorrow the construction guy may shaft a beam not in the exact location which is as per the drawing plan, or maybe the contractor wants something to be changed, and architecture has suggested something like, let's change the washroom area, maybe increase or decrease the size of the room, and that has been done, but at the same time that may not be documented, okay, because of the lack of resources. So now that can be another challenge, like whatever you work, and again it needs to be reworked. For an example, if a beam has been created or casted out at a wrong place, then the shifting of the beam, maybe chip in and filling of the beams needs to be done. That can lead us for the cost of rework at the site itself. ultimately, all these factors can actually cause like the delays in most of our projects. And in fact, that is what we are seeing right now as well. So in fact, like as per the recent study from the Ministry of Statistics program in India, so we have like more than 1,700 projects to be delayed from 45 to 60 months. Some of them can be or like are because of the COVID, but some of them are also leading for the delays because of the lack of resources from the site. The documentation has not been done correctly. The timeline which they have decided is not actually like, based on the real number from the site. So the scan to BIM conversion or like these sort of technology, like the laser scanners, photogrammetry are playing a vital role to resolve these sort of issue and to overcome these sort of challenges means in their upcoming or in their current construction projects itself. So as we have seen, what are the current challenges? So what I will do now, I will start from the term I think which you will be keep on hearing from me, and as well as from the people who are using the laser scanner or the drones. So they must be using the term point cloud, which is a pretty common term nowadays. So most of the construction professionals are aware about the point cloud data or the term point cloud. But if I quickly brief you about what exactly the point cloud is, so the point cloud are basically the data points which has been captured from the space or from your surroundings by the help of a laser scanner, or it can also be captured by the help of a drone as well. Ultimately means these points are or this point cloud information is nothing but the million of points which has been captured from your surrounding. And when I say the million of points, so they not only consist of the X, Y, and Z information of the site, but they also collect the information such as the RGB, the color value, the orientation angles, and all those things at the same time from the site itself. So when we do the documentation of the part, so all the raw data which comes or which has been generated, I would say like in terms of 3D scanner, so that has been that is known as point cloud data. And once we collect the data, that data can be later on processed or to be used inside the CAD modeling software. So for example, like if you're a construction engineer, because today we have, I believe like most of the people are from civil and construction. So it may be possible that for the construction industry, they may need it for BIM modeling, okay, or for maybe creating 2D drawings for the site. Whereas if I talk about for the mechanical engineering part, so they may be looking for some components to be scanned, and later on that component needs to be converted into an STL file or a mesh file, which can be maybe go for reverse engineering, retrofitting, or maybe even for 3D printing as well from the site. Similarly, if people are from the quality inspection and quality control, so they can also use this data to ensure that what sort of quality they do have of the site. So tomorrow, let's say like, I have a building, I want to see the plumbness of the wall. I can actually see that by the help of the point cloud data, which has been captured from the site. So if I talk about the point cloud, the bigger picture, so the point clouds can be used from all the discipline. We have people from movie industry, we have people from gaming industry, we have people from construction, civil, plant or oil and gas industry. So we have like various disciplines where these data can be used as per their own requirements accordingly to the site. I have a quick video which I would like to show you, and in this video you can actually see and relate with the term point cloud data and how the point cloud look like. So this video has been recorded, has been captured by one of our the active user who's keep on doing the laser scanning from the site. And right now on the screen, I think you can see the video. So this data has been captured from a heritage site where they want to document the complete site information by the help of laser scanner. So they have been like scanning in not only in the construction environment, they also been scanning in the areas of forest, maybe on a rail track or on a rail station. They have been scanning tunnels. So to extract the tunnel profile, they have been using the scanner to capture the mosaic or maybe the paintings, building spaces. We also have like plants, heritage, foods. So all this data which you are actually seeing on the screen These are nothing but the million of points which has been captured from the site, and then they have been stitched together to make a complete 3D geometry. So right now you can see we have like cases from the police department, like a burned bus or maybe an accident scenario. We have piping. The complete piping can be scanned by the help of device. So if you want to make a complete as-built piping for maybe, let's say, for your buildings, for your plant, or maybe for the internal of a ship as well. So we can also use the same laser scanning technology, and that can collect all these point cloud data from the site, and later on it can be used for 3D modeling, reverse engineering, QA/QC, and even it can be used for the visual representation or for the digitalization of the data itself. So this the scanning or the point cloud can be from a small component, okay, or can be of a small object, and it can even be up to a large area such as of a complete city, where you can do the scanning by the help of these devices. So I hope like this video help you to understand about the term point cloud data and how it actually look like on the site itself. So I think before proceeding to my next slide, I believe that the point cloud may have given you a clear idea that what exactly the point clouds is. And now, as I mentioned, the point cloud data has been generated or has been captured by the help of 3D laser scanner. So next question could be like, okay, what exactly a 3D laser scanner is? Okay. So you may have seen that there are multiple devices in the market, like there are 3D laser scanner, there are aerial photogrammetry devices, like, the area based on the camera. So currently during our today's session, we will be discussing more about our 3D laser scanning system, which has been offered by Fero. But if I talk about the concept of the 3D laser scanning, so this has all been like the same. So we, in this video, you can actually see. So what we do have, you can see this device, which we do have. So this is the Focus X series laser scanner. And in this video, you can actually see that in the device itself, so we actually have a laser source available or to be present inside the scanner body itself. And then that laser start emitting. The moment we start scanning, the laser start emitting or strike out on the mirror head, which is situated at the center of the scanner. Once it strike on the mirror head, then it starts reflecting outwards to capture the surroundings. Now, the thing is that the moment it start hitting the surface, it come back and collect the XYZ information. It's actually similar to what we have seen with the other devices, whether it's a distance meter, where you take out a distance meter, strike a point on the surface, and it show you the reading that, what is the distance between the object to the position where you are standing. Similar to that, we have the same technology. We have the same laser, which goes strike to the surface and come back to the scanner along with the XYZ and as well as with the colored information. But the good part or the major comparison between both of the technology is that in the case of distance meter or even with the total station, you are actually being able to capture a single point at a time. Whereas by the help of this device, you are actually capturing near about 2 million points per second. So as you can see, the device is not only emitting the laser in one direction, it's actually rotating in both of the axes, like horizontally as well as vertically. So as a result, and if I talk about the measurement speed of the device, so it's actually a 2 million points per second measurement speed, which the device is giving. As a result, the data, which you will be capturing even with a single scan is going to be enormous if you compare it with the traditional or with the conventional method. So that's why we keep on saying that, when we talk about the laser scanners, we are looking for a fast device to capture the site information accordingly. Okay. And while proceeding with the same, again, there are two different type of laser scanners which are right now available in the market. And in fact, I think one of the common term which you may have also heard about is the LiDAR. Okay. So we actually work on the same principle of LiDAR, where a light is, where a laser source emit a laser, come back and collect you the information. Now, the only difference when we talk about a LiDAR, so LiDAR usually work in a single direction. Okay, so we do have a beam which can work in single direction. Now, it can be a single beam LiDAR or it can be a multi-beam LiDAR. But when we talk about a laser scanner, so laser scanner can actually do the scanning in the complete 360 environment in one go. So that make us different. But if I talk about the fundamental or the technology aspect, so they both are actually the same. Now, in this case, as you can see, like we do have two type of laser scanners available right now in the industry. I'll not go in much more detail because I guess like we have some experts and some students who have been keep on researching in both of these disciplines. But if I quickly summarize or brief about it, so from the laser scanning source, there are two methods. Like you can see in the blue, we do have phase shift and the time of flight. When we talk about the time of flight laser scanner, so it simply emit a laser, come back and collect the information, the distance, the time taken between the traveling of the laser that has been documented, and as a result, we have captured or calculated the distance. Whereas in case of phase shift, what we are actually doing, we are also calculating the medium in which the laser is traveling. And as a result, when it comes back, so we have more precise information of the site itself. So if we talk about the simple fundamental or the simple formula of calculating the distance. So in case of time of flight, it's simple. So you can see like the time duration which it has taken from emitting from the source, emitting and then receiving back, that has been calculated. And this is what the formula where you can put in. And in case you're interested like how it works, so you can actually put in the values and you can derive the exact the distance of the site. Now, the good part is that the device is intelligent enough to compute all these things for us. And as a result, the output is what we are getting is the simple, the X, Y, Z values. And later on inside the software, we are actually going to compute all the measurements and everything. So you have seen like when we talk about the time of flight, we only rely on the distance. We are not concerned about the phase. But when we talk about the phase shift devices, like the ferro laser scanner, so it also considered the phase in which it's traveling, the laser is traveling. The good part is that when you compare with both of the technology, they both have their pros and cons. Like if I talk about the time of flight laser scanner, they are the one which actually can do the scanning up to a larger distance. So if you're using the same configuration like on a tripod, so in the market, there are scanners which can go or which can scan up to a distance of 2 kilometers, 4 kilometers, and even up to 6 kilometers. So those are the device which were using the time of flight technology, okay, where the laser needs to be emit up to the larger distance. Whereas when we talk about the phase shift devices, so these are the short or mid-range segments where the laser can actually go and travel up to a distance. Like in case of ferro, we have a largest distance of up to 350 meters. So a single laser can actually travel up to a 350 meter depending on my line of sight, and it comes back and it can give me actually the information of the site itself. So the phase shift method is what we are using. And if you compare both of the technologies, so the time of flight can give you a longer range, but the lesser accuracy. Whereas when we talk about the phase shift, they can give you the lesser range, but the high-end accuracy can be achieved by these devices. Okay. If we have started about the laser scanner, I think I'll also go quickly with the history of the laser scanner. So the laser scanners are actually not, I would say, not new in the industry. The laser scanners have been, I think, start getting to be used in somewhere in 1990s. And I think one of the first founder of this technology is Ben Kaira. So he's from the Kaira Technologies, who make the world's first laser scanner. And after a few years, that scanner has actually been able to be available for the users. So at that time, he mostly using these technologies for documenting the large spaces for the heritage part and even for the heritage evaluation. In fact, like if you want to go read about like the stories about the Ben Kaira, so you can also see the one of the because earlier he used to do the laser scanning development, but now he's totally in the heritage and preservation work. And he's actually one of the founder of the SIAC technologies or SIAC organization. So SIAC is the one who has taken an initiative of scanning 500 heritage monuments across the worldwide. And they have actually done the phenomenal job of doing the documentation of most of, of all the 500 sites on the site. So if you want to go through his work, so you can actually visit Syra. You can just go to Google and type in SIAC 500 project, and you will see there are 500 projects which has been listed from the site from different heritage aspects, and they have been documented and they have been virtually preserved in their website itself. But if I talk about the technology, the old technologies, the moment when this all started, so, the entire setup is different. Like, we have a laser scanner, then we have a separate battery compartment available with it. Now, to move the entire system is like pretty much a task back in those days. So the entire system is somewhere around 40 kg. Okay. And if we talk about the measurement speed at that time, in the initial time, so they do have a measurement speed of 1200 points per second. And the distance limitation in the initial days is of up to 50 meters. So up to a 50-meter distance, you can actually be capturing 1200 points per second. But if you compare it with the nowadays technology, so nowadays the scanners are getting more compact, okay, and more compatible. They were getting more versatile. When we say the compact, so like the one which we have supplied, or one which is available with the IIT Palakkad, that scanner is only having a weight of around 4.2 kg. Now imagine, like, 40 kg to 4.2 kg. Yes, it has been a long path. We have traveled a lot. And at the same time, the measurement speed is also keep on increasing day by day. So in the old times, they do have 1200 points, but now we can actually capture up to 2 million points or 20 lakh points per second at the site, and with even a longer distance. If I talk about our offering, so what we are actually offering currently, so we do have a complete portfolio for hardware and as well as for software. When we say hardware, we do have some precision devices which is being used by reverse engineering product design. So people like Boeing, Hyundai, and other automotive industries, they are extensively using our systems like FerroArm, ScanArm, laser tracker, the laser projectors, and so on. For the construction industry, we have specifically these products, that is the laser scanner, handle scanner, 2D mapper, mobile mapping system, and the augmented reality system. Currently in IIT Palakkad, we have supplied this laser scanner, and maybe you guys have seen it on the site itself, because I think we have people or students like Nikunj, who has been keep on doing the research and development in the field of laser scanning, and currently he's using the same FerroFocus S Plus 3D laser scanner for doing the documentation and for his research purpose. But not only the laser scanner, we do have other systems as well. So the good part is that when we talk about the Ferro scanning system, they are more versatile. So the same scanner can be used in multiple configuration. And in my next slide, you will see that how this scanner can be used in multiple setups. Not only the hardware, but we also have a complete set of software solutions. So we have software for quality control inspection. We have software for QA/QC, or the construction QA/QC. We have the complete range of software for crimes and crash scene investigation. And last but not the least, for handling your point cloud data. So we do have 3D point cloud registration software as well available with us. If I talk about the laser scanners, as I was mentioning, so we have this laser scanner available with us, the Focus 3D laser scanner, which can actually have a range from 70 meters. So we have different models depending on the need a user can choose. Now, the good part is that, like, the standoff distance from the position where the scanner has been placed and the farthest distance. So the traveling distance, the radially we are capturing, and that's what we do have as 70, 150, and 350 meters. So if you are if you need any scanner for the indoor, maybe the 350 meter may not be suitable. But if you want to scan the outdoors, then maybe the 350 meter or 150 meter can be more suitable product for you. So depending on the project requirement, actually a user can choose between different technology and between different setups on the site itself. Now, the good part is that not only the range of the scanner, but also in terms of the accuracy. So the Ferro S and S Plus series laser scanner are having ±1 mm accuracy on the site. Whereas when we talk about the M70 laser scanners, so we do have the accuracy of ±3 mm available with us. So again, if a user wants to choose, like, if we need, if usually, like, if somebody asks us for an entry level scanner, then we do have M70. If somebody wants a high-end scanner with the high-end accuracy, then we do have the S and S Plus series laser scanner. We also have some 2D mobile mapping system. So similar to what you may have seen as a distance meter, we do have this scan plan device, which is basically a 2D mobile mapping system. And you actually need to just hold the device in your hand, and you just need to start walk around your area or into your site. The moment you start walking, it's actually start creating a 2D drawing on the screen of your scan plan, which can be your mobile phone. And at the same time, you will be getting a real-time preview of the complete lines, the sketches, or the wall information available with you on the site itself. Then we do have the handheld laser scanner as well. So the Ferro Freestyle 2 is the handheld laser scanning segment where you can actually do the close range laser scanning from the site, and the object can be scanned by the help of this handheld device. Now, these devices do have their own accuracies, their own objective to be resolved. So when we talk about the handheld laser scanner, this device is being used for the areas where we do have the complex environment, like, where a terrestrial or a tripod-based scanner cannot be placed. So in those areas, in those tight spaces, you can actually do the scanning by the help of this handheld device. Now, when we talk about the handheld device, so the accuracy which we are having is around 0.5 mm, and it varies according to the distance in which we are capturing the data. So the accuracy can be from 0.5 if I'm standing at a distance of 1 meter. If I stand at a distance of 5 meters, so the accuracy goes somewhere around 5 mm. And the maximum distance which I can have for capturing is of up to 10 meters, where the accuracy goes up to 15 mm. So depending on my need, I can adjust my distance and I can ensure my data accuracy accordingly on the site. Now, if you compare with the other setup, means with the Focus 3D, so this device is having a lesser number of points and measurement speed. So this device can capture somewhere around 220,000 points per second. But the good part is that, like, this can be used in all sort of compact spaces where a Focus 3D cannot be placed. So as a result, this make it unique and more useful for the site itself. Now, the other thing which we have is means what Ferro as a Ferro we offer to the user is that of versatility. Our system can be used in multiple configurations. So as a result, we said that, or we come to the conclusion that it's moreover like a versatile system available for the site. Not only that, the data which we are capturing is actually means we are hoping that a better data can be captured from the site, and at the same time at a faster speed. So by keeping all these thoughts in our mind, we have actually launched the complete range of the automated and not automated platforms where the device can be integrated in all of these arrangements. Now, starting with this one, so we do have the first platform is the Swift, where the device can be fit in the same laser scanners with some add-on firmware. So you can actually use the same Focus 3D laser scanner on the top of a cart along with scan plan device. Okay, so whether if you want to use it separately, you can use it as a 2D mapper. You can use the terrestrial, you can use the same scanner as a terrestrial scanner. But when you merge both of these technologies together, then it becomes a Swift mobile mapping system. So this system can actually help you to do the scanning for a large space. Okay, when I say large space, so if, for an example, like if you want to scan a big complex building, okay, or maybe a shopping mall, then you may don't want to spend more time on data capturing side. So to overcome that part, we have actually released the system, the Ferro Swift system, where you can actually put it on a trolley, and while moving the cart, you can actually do the scanning on the site itself. So this actually helps us to do the data capturing at a much faster rate. In fact, my next slides, I do have some recordings and some videos in which I would like to show you the same as well. The same, this is moreover like a human-driven cart, where a human need to get involved and he need to drive the cart accordingly, like wherever the data needs to be captured. But we also recently launched an autonomous laser scanning system. So in this part, like we have a collaboration with Boston Dynamics. where we are using the Focus 3D laser scanner on the top of a robot dog, that is the spot. And when together we make a product named as FerroTrack now. So this FerroTrack is intelligent enough to go to the site automatically on or based on your the project plan. Okay, so based on your waypoints which has been defined or feed in inside the controller of the robot actually go to the site, trigger the scanner, take the scan, and then once the scanning is done for your entire site, it can come back to you. You can collect the data, you can do the processing, and you can proceed for your next project. So the complete autonomous system is what we do have now by the name of FerroTrack. The same scanners means the Ferro systems can also be used on the top of a vehicle. So we have the complete mobile mapping system as well. So this setup can be used for the people who have been doing the large space scanning. Let's say means maybe for a city, or maybe if you want to scan your entire campus, then this can be the arrangement which you would like to have. So you can drive your car and while moving your car or while driving, it's actually keep on collecting the data, and all this data information is going to be stored inside your laptop or inside your SD card, whichever you're using as a storage device. And later on, it can be used for further evaluation. If you want to go for 3D modeling, maybe taking out the 2D drawings of the roads, whether it can be a cross section, road profiles, everything. So they all can be extracted out by the help of this setup. And last but not the least, we also can use the same laser scanner or to be compatible with a drone configuration. So when we say like with the drone, so the same system can be configured with some add-on accessories. So you need to get a LiDAR port, which looks like this. And this LiDAR port can be mounted at the bottom of the drone, and then you can take or do the complete scanning. These sort of scanning can be useful for the people from, let's say, from the mining side, okay, from the mining industry, where they want to scan the complete open cast mine. I'm not saying the underground, but for the open cast mine, this can be a good tool. And the moment it take off, the scanners start capturing the data. And at the end of the day, or maybe in a flight plan of like 15 minutes, you will be able to capture the entire site accordingly. So these are some of the platform where the Ferro laser scanner can be used or can be integrated with them. Now, if I talk about the Ferro Focus Swift, as I mentioned, the cart. So this cart system can actually do the scanning of the larger area. If I talk about the scan area right now, so we are covering near about 500 square meter of the area to be covered every minute by the help of this device. So as a result, when we say the data capturing speed has actually gone faster if you compare it with the traditional technology. If you talk about the accuracy part, so again, because it's a mobile platform, so the accuracy is not as precise as the terrestrial or the tripod scanner, but still we are able to achieve somewhere around 2 mm for a distance of 10 meters. So this sort of accuracy has still been achieved by the help of same Focus 3D system along with Swift configuration. Now, the good part is that this system actually offers you the versatility to choose between 2 different configurations. You can take out your tripod, you can use it as a terrestrial scanner for your site. So let's say if you want to scan a building, maybe you don't want to use it in a cart configuration. So you can actually take out the tripod, you can take the terrestrial scan, the high resolution one with the high-end accuracy. Tomorrow, let's say if you now want back on, or you have a project need of the mobile scanning, then you can put the tripod on the top of your cart and you can do the mobile scanning itself on the site. So this make the system more unique or more user friendly to the people from the construction part itself. So I have a quick video in which I would like to show you a quick the workflow of what we do have from the Swift system. So in this case, as you can see, we do have near about like this constructions, this warehouse or a plant where we have been using the same Swift to be for capturing the complete data or to capture the complete site information. Sorry. So now if we talk about for the data capturing, what we simply need to do, we need to plug all our devices into the location where it needs to be placed. So like on the top, you have Focus 3D. The bottom, you have the scan plan on the top of a tripod. And then at the bottom part, we have the trolley system. The good part is that like the FerroFocus Swift system do offer you a complete set of freedom of choice. When we say freedom of choice, so as I mentioned, like you want to have a quick data capturing, so you can do it in this way. While moving the cart, you can do the data capturing. If you want to go for a high-end accuracy, then you can actually go for stationary scan. So you can stop your cart, click on the device, means during the mobile scanning itself, you can choose the stationary scan or the high-end scan, and the data can be captured accordingly. Now, to do the comparison with the traditional scanning method, again, in this part, you can see we have done near about 24 scans at different position in this tripod configuration. Whereas in this case, we are simply moving out our trolley in all around the area. Okay. So for the same site, we have taken near about 24 scan positions. And each scan position has taken around 5-minute time duration. Now, when we go in total, so with the Swift system, we have spent near about 8 minutes on data capturing. Whereas with the traditional scanning system, we have spent near about 120 minutes for capturing the site information. So you can actually see that, this device is actually much more faster, means than comparing with the traditional method. So a user can actually choose at any point of time which configuration is needed or which accuracy is needed for their project requirement, and they can use it accordingly at the site itself. So as I mentioned, so what we do have in the Swift, we have the same 3D laser scanner, the Focus S series or S Plus series laser scanner. Along with that, we have a firmware. So it's a simple firmware needs to be enabled. All the scanner which Ferro provide is having a Swift configuration, but to enable that Swift configuration, we do have a firmware license which needs to be installed inside your scanner. And along with that, then we do have the scan plan and the mount where the scan plan has been placed. A mobile phone, which is going to be used as a controller. So any mobile phone like an Android or iPhone can be used. So you actually are not using any specific app for this. We are simply accessing the Wi-Fi of the devices. And based on that Wi-Fi, we are connecting our mobile phone to be used as a controller for both of these devices. The good part is that the entire system is wire free. Okay. So you don't need to run like cables and other things for capturing the data or for connecting with each other. They all work within the Ferro ecosystem, and they all can be interlinked all together with in this case, the Focus 3D is connected with ScanPlan Wi-Fi. And at the same time, my mobile phone is also, or the user mobile phone can also be connected with the ScanPlan. And this will keep on collecting the trajectory wherever I'm moving the cart. And at the same time, it's also applying the timestamp on my laser scan data, which has been captured from the site. So every point where my cart is moving, I'm also implementing the laser scan data. And when I do the final process, I actually get a complete 3D surrounding in one go or in one step itself. The other system which we do have is, as I mentioned, an autonomous laser scanning system. So in this case, we have this product, the Ferro Trek, which is a joint collaboration between Ferro and the Boston Dynamics. So in this case, what we have done, so we have combined both of these technology together, where the Boston Dynamics spot can give us a complete mobility or the choice of using the autonomous laser scanning platform. So the device means we just need to feed in the, let's say, the flight plan, similar to what we do in the drone, and that's it. Now the device will go to the site, do the data capturing and everything, and come back to us accordingly. Again, this is based on the requirement. So if we do have a large or complex sites where maybe some hazard could be there for the operator, or maybe the human involvement need not to be there. So in those complex areas or the complex site, this device can go and do the scanning. Now, the good part is that like all the scans have been aligned or have been captured with respect of the trajectory where the spot is moving or where the robotic platform is moving. So as a result, we have a stitch data, already a pre-processed registered data. So all the scans are already positioned in the location wherever it needs to be. The good part with the spot is that it can actually climb stairs. So if any change in the level, you actually don't need to shift your device. The spot is intelligent enough to climb those stairs, reach to the another level, do the scanning, and then come back to you. So I have a quick video on the spot as well. So let's have a look of the spot. So when we talk about the spot, as you can see, this is the main setup, the main robot. And on the top of it, we have the Focus 3D laser scanner. In this case, this is the S Plus, and along with a spot core. So the core and the scanner is provided by Ferro, and the robot, the autonomous robotic system, is being provided by the Boston itself. So depending on the user need, we can actually do the requirements, or we can use it accordingly. So now you can see whenever I need to go, means if I say like I need to scan 2 different floors, the spot is intelligent enough. It go to the site, it stop, it hold the position where the scan needs to be done. So now you can see the spot is in stationary position. It done the scanning. Now it again start moving to the another location. So it's moreover like, you know, a stop and go configuration. The device itself go to the place, start scanning. Once the scanning is done, then it will shift to the another location, again do the scanning. And at the end of the day, you have a complete pre-position aligned data all together from the site itself. So I think somebody has raised hand. I need to see like who exactly he or she is. So is there any question?
No, sir.
Okay.
So we continue.
Yeah. Thank you, Nikunj.
Oh.
So if we talk about the spot, so these are some of the images. Again, this test has been done at one of the facility of Oracle Engineering. So we have been extensively doing the testing, and in fact last year we have launched this product in the market. So due to the COVID, there are some certain delays, but I think we are still being one of the first companies who have been commercially available, getting this product to be available for the market for the laser scanning requirements. Then we can also use the same scanning system as I mentioned on the drone configuration. In this case, you can see that it has been mounted on DJI Matrix M600, and the same scanner can be mounted at the bottom along with the LiDAR pod, and it can go to the site and it can do the scanning. So if you see in this video itself, so in this video, this is the main setup which has been done. So again, for this part, we have an integrating partner with us, Sabre, who has done the collaboration of both of these technologies. The moment you start flying your drone, you just need to feed in your flight path and everything. And the moment it take off, it actually start doing the scanning from the scanner side itself. So now in this case, they have actually been doing the scanning for an open cast mine. And now you can see the scanner is still keep on capturing the data, and it's just taking a walk around the complete site. And we get the complete scanning output once we call back the device to ourselves. So all the device, all the scanning data is actually going to stored inside your SD card. So you can take out the SD card, you can process the data in your laptop, and you're good to go with your complete open cast mine data within a single flight. Now, this thing can be customized again, based on the requirement. If somebody wants to have a color data, so an external image capturing camera can be mounted at the bottom of a drone along with the scanner as well. And later on during the processing part, we can actually stitch those images also along with my laser scan data. But again, it's totally depend on the choice of the user. So if you want to use it with color, you can have that additional color option or the color accessories. If you don't want, then you can also use it without the color information as well. Okay. So again, this entire system can actually give you a complete freedom of choice to be used, in the aerial configuration mode. The same device can also be used, as I mentioned, like on a card. And in fact, in my next slide, you can see the same device also being used on a car as well. So for this part, like again, if you want to scan a large area, like maybe a city, a town needs to be scanned. Like nowadays in India, we do have lots of smart cities development, which is keep on happening. So the same device can be used for those applications as well. In fact, like globally, we have been means in the Asia itself, like we have people from the construction. We also have people from the police department who are using this card system to understand the areas where most of the accidents is keep on happening. So for example, if there is any specific intersection where the accident happened, so nowadays what they were doing, like they were virtually documenting the site, and later on inside in their office, they look for the root cause, like, what are how many blind spot they do have in those particular area where the accidents keep on happening, so that they can have a better management or better planning at the site itself to make the roads to be safer for the users or for the people on the industry. Sorry. So the good part is that, like, again, the scanning can be done in both configuration. Right now, which you are seeing, this all data is not been captured by the aerial. This has been captured by the card-based system, the vehicle-mounted mobile mapping system, and we are just driving around the street. Now, the device is this is an older device which you're seeing on the screen itself. So this device is having a 330-meter range. So all the objects which are coming within the line of sight 330 meter, we are actually being able to capture all those information, all those features accordingly. If you see the data, so from the road point or from the road prospect, we not only getting all the road information like the center line, the medians, the markings and everything, but also if somebody wants to go for the street pole, how many street poles we do have, where are the dividers, the medians, even the bridge height for the road clearance, they all can be captured, evaluated accordingly on the site. So if tomorrow somebody wants to go for, if you want to say like, I want to go for the floor flatness of some particular area, or even for this road, we can actually see the levelness or the flatness. So all sort of like the corrections and the construction needs can be fulfilled by the help of these laser scan data, whether it can be captured by a terrestrial or it can be captured by this mobile mapping system from the site itself. Again, in this case, we also have the same freedom of choice. So a user can choose between the color and black and white. So usually in the road cases, we don't need the color information. So in this, you have not seen the color information. But if you want, then we do have a boom lift, which can be mounted at the top of the same scanning system. And that boom lift is going to capture all the images from multi-direction. So it's having like 6 or 8 camera arrangements on the top. And it's going to click images from all the sites. And later on, during the processing, we are going to stitch those images together with our scan data. Okay. So I think these are some of our solutions which we do have right now available for the industry. And now I will quickly go through some of the sample data sets or the sample which has been captured by the devices. So this is one of the example where one of my colleague has done the scanning so he's based in UK. So he has actually done the scanning of this church. Now you can imagine like it's not a small area, like, this church is like, this is a quite huge. And while moving the cart or by the help of the Swift mobile mapping system, he's actually been able to manage to capture all these information. Now in the video, you can see this orange line. These are the trajectory where my cart has been moving. But at the same time, you can see the amount of detailing which the device has captured is pretty good. Okay, so from this data itself, we can actually extract out all the information. So for example, if you want to go for the arch length, you want to see the size of the columns or pillars. You want to see the placement of the chairs as well for in case of some event planning. They all can be done by the help of this device itself. And to capture this amount of data, if we only spend like 2.5 minutes. So within a 2.5 minute duration, he actually been able to capture this entire information, which you just have seen on in the video by the help of FerroSwift mobile mapping system. In another example, we have, so the same Focus Swift system now can also be used for the outdoor environment. So we have been scanning for the outdoor. So in case of the outdoor, let's say the main objective is not only to capture the road, but also the facade of the buildings. So what we have done, we have taken out our card-based system, the Focus Swift, and we start moving the card along on the sideways of this road itself. And the amount of the data which we are actually being able to capture is you can see, like, enormous. If you want to locate the street pool, you can do that. If you want to locate the width of the roads, you can do that. Markings, any like detailing even of the buildings, they all can be seen, they all can be read out from the scan data itself. And it's actually make it more beneficial for the user part itself. So depending on the project need, if he just want to go for, let's say, creating a 2D drawings of this roads itself, so he can do that. If they want to make a 3D model also, he can also make the 3D models. And even the elevation plan or the facade drawings can also be generated from the same scan data. So now you can see this is the location where we have used our cart, where we have placed the cart, and the cart is keep on moving from that end to this end. Now, this is actually a small patch of the entire project, but if I say the entire project, so it's somewhere around more than 4 kilometer stretches there. And to capture that 4 kilometer data, he has spent near about like, I think around 90 minutes of the scan time. And within the 90 minutes, he's actually been able to capture the complete 4 kilometer road stretch from their site itself. Now, here's the another example, I think, which we do have. So for the indoor, like underground car parking lot, so this has been captured while evaluating the device setup itself. So now in this data itself, you can see the amount of detailing which we are capturing or which we do have is quite enormous. You can see the running pipes on the top as well. Any signboards, any markings is there, like the exit signs, the pillar numbers and everything. All those labels have also been captured. And all this information have been captured only by the help of the black and white data. We are not actually even using the camera available on board. So if I want to use camera, you can imagine, like, merging with the texture information with the real-time texture, how nicely it may look. And if tomorrow I want to evaluate, I can do it accordingly. Later on means from the same underground parking lot, if I want, I can actually compare or I can extract out a 3D model out of it. So to do that, we do have a software named as As-Built Modeler. So inside the As-Built Modeler, what you can do, you can actually take out a cross section like a vector map. You can quickly create a vector map. And from that vector map, I can actually pull out all these informations of the wall, columns and everything. So in this case, you can see what we have done. We have taken out these green lines, which has been traced out from the laser scan data as a cross section. And now I'm just going to extrude those lines. So the extrusion of the lines help me to extract out these walls and the other elements of the columns, pillars, and everything from the site itself. So now you can see like how easy it can be, like, for modeling out the information from the site. Similarly, if you want to create out the surfaces, so we do have region command where you can also create or take out the surfaces from the site itself. Okay. So the As-Built Modeler is the tool which can help you to create a quick 3D model out of your scan data by the help of some few clicks on the site. Now, similarly, if you want to go for the construction monitoring or construction QA/QC, we call it. So for the QA/QC part, again, what we have done, we have sliced out that parking lot. We have extract out the surface, the planar surface from it. And then we are actually comparing the point cloud data with respect of my plane. So once we run the analysis, so this is like the surface deviation analysis. The good part is that, like, once the comparison is done, we can actually see this sort of heat map generated by the scan data. So once it's done, you can actually see the high points, low points, or anything. So if there is any undulation on the surface, they all can be easily seen by the help of this complete method. So now in this case, you can see the heat maps, and now this needle size can be customized. So these needles are pointing the points which are outward or the inward. So greens are one which were the stable, the blue ones are the low points, and the red ones are the high points. So you can easily identify from the site itself, like, whether it's having a complete plumbness or not. And in fact, in my other slides, I'll show you some of the real example from the site that, what could lead us or what may cause the issues or means of because of the wall plumbness or the floor flatness itself. So again, this is one of the example where you can see we have captured this device, the data of the underground car parking. We have converted into a 3D model. And then from the same data, we can also do the QA/QC for my construction site itself. So now at any point of time, in other countries, actually, that the same technology is also being used for the floor flatness. So like at the time when they were pouring the wet concrete, so they means at the same time they do the scanning. So the moment they pour the concrete, they take the scan and they analyze, like, at this point of time, is the flatness is correct or not. Initially, or like in old times, what they used to do, like they used to go for the deep stick check, okay, or total station, they map out a couple of points, create a plane, do the same. But now, by the help of the same scanner, they can actually take a single scan, the wet concrete is there, and while the concrete is curing, at the same time, they can actually do the changes of the variation on the site. So as a result, the construction rework cost or the wastage can be reduced drastically. Okay. Now, here are some other examples where we also have done the same jobs, means for the plant and piping industry. So for the plants, like in this case, this is a chemical plant where we need to generate the as-built model or the as-built drawing. In the case of the plant or the facilities, what used to happen that they don't have an updated drawings. The plant may have been created like maybe 30, 50 or 80 years ago. And during that entire period of time, there may have been lots of changes which may have been happened on the site, but the updated drawings may not be available. So as a result, what we used to do, that we go to the site, we do the scanning. You can see a little bit transparency, the transparent points. So those have been captured by the scanner, the Focus 3D scanner. And then inside the as-built for AutoCAD or inside the as-built for AutoCAD for the plant 3D, we can actually trace out all these pipes with a semi-automated way. So we just need to click a point on the pipe, and then the pipe size will be measured and everything can be captured accordingly. So I think Mr. Rajiv Kumar has raised his hand. So Nikunj, can you unmute him?
Yes, sir. Raju, sir.
Yeah. Mr. Mohit,
Yeah.
my point goes to the quality Q and QC role. You see, the effectiveness of a 3D scanner in ensuring the measurement part. Can you highlight that part, like the building heights, building dimensions? Like we have got a building, you move the 3D scanner within the building, so it will take the inner dimensions and all the dimensions will come. Similarly, you have to then take the outer dimensions. You have to move the 3D scanner outside, so then it will be able to generate the entire dimensions of the buildings. Now my point goes that when you have to measure the thickness, the tolerance in the length and width can be 1 mm, all right, but when it goes to the height, the thickness part, like particularly you are measuring the thickness of the floor, so it will be effective in doing so?
Yes, sir. Means when we talk about for like, let's take an example of the floor flatness itself, or let's take an example of the thickness. So because the scanner is having an accuracy of plus minus 1 mm tolerance. Now, when I say plus minus 1 mm, that is a single scan accuracy. But the moment I stitch the data together, Again,
Yeah.
like depending on my overlap, that accuracy can be increased or decreased.
Okay.
So the precision of the data is totally based on how I am executing the site scanning. Okay. We
Okay.
example where we have scanned the site, like even lesser than the tolerance level, means somewhere around 0.6 mm. So we have been scanning at a site in Gurgaon. It's for a construction company where when we have stitched together near about 8 scans of a complete raft, because the construction needs to be done, and it was at the basement level. So when they have extracted out all the volumes from the bottom of the building while constructing the basement, we have actually been able to get an accuracy of the scan data of around plus minus 0.6 to 0.8 mm.
Okay.
Now, the good part is that when I bring that data inside the software for the QA/QC, because I'm not even going for the 3D modeling part right now. For the QA/QC, what I will be doing, that I'll simply create a mesh file, a complete curvature or the surface for the pit. And I'll also take a plane, I'll create a plane from the top of it. So let's take an example for the volume calculation. It can be precise because for calculating the volume itself, I'm getting more number of points. Similarly, for the floor flatness, because I'm not relying on, let's say, 10, 20 or 50 points, I'm relying on million of points, which has been captured from the surface. So the tolerance level for the report as well will be higher than the conventional methods. Okay. And this sort of like floor flatness and other things, we actually have the software built-in construction where we have industry specific standard. So like, for example, we support ASTM standard. We also have CS, the Concrete Society, TR34 standards for the floor flatness as well. So in fact, like all these standards which or the reports which we are generating are based on those standards of the industry itself.
And is it able to compare the camber of the surface, like we have got a runway surface where these flat, I mean the desired camber, the slope on either side of the center line or the longitudinal slope, both are quite important. So how do you see the effectiveness of this equipment over there?
So when we talk about, sir, like I think inside the built-in construction, we have a complete set of tool for the camper deflection. Okay. So for an example, like if like in case of, I think last time when I used that specific tool is for the structural engineering companies, where they do have old establishment of the plants and the beams, they want to see like, how much tolerance it's getting, the inward or the outwards. So they use the built-in construction for that, and we have it services for them. And in fact, in the industry, we have like multiple structural engineering companies who have been generating these reports based on the scan data and submitting to their clients. And they have been doing it for, I think now more than, in India itself, I would say like, I think last customer, near about like 3 years, more than 3 years, they have been using this service and providing the solution to the customer.
Just one more point. That what is the cost of that your scanner 3D scanner of 350 meter, which gives you the accuracy of around 1 mm or so?
Yeah. So when we talk about, sir, the cost, again, it doesn't only restrict it to the scanner itself.
Okay.
As I said, like I'm mainly responsible for the technical, but if I a ballpark figure, so the scanner from 70 to 350 meter, depending on the software also, because we are not only providing you the scanner, along with the scanner, there will be software as well.
Software now, as well.
Yes, the software customization can be depending on the needs or the requirement.
Okay. Okay.
So if you say I want to go for a 3D modeling after means like the scan BIM conversion, then there will be a cost. If you say I only need a progressive construction monitoring, like I will run the wall plumbness, floor flatness, then maybe remove the BIM part, the as-built part, and we include the built-in construction.
Okay.
Yeah. So if I talk about, sir, only the scanner and the hardware cost, I think it can start from somewhere around 30 lakh and it can go up to 70 lakh.
Okay. Okay. Okay.
Again, this is from the higher side. I think once you get in connection or connected with the technical, with the sales team of our, So they will get
Okay.
you the exact figures on what will be the.
Oh,
Okay.
Okay, and you provide the customized services also, like we give one particular project to you and say that this kind of service is required from you, and can you do that for us also?
Currently, sir, means as a Faro, because we are the OEM, so we don't do services directly, because
Okay,
we have, like, the customers who are giving the services. So it may
okay,
not sound faithful to them, like, in terms
okay,
of profession.
okay,
So like Faro is directly not doing any service, but we do have some partners with us who
okay,
support us for the sales and as well as for services. So
okay,
for example, if you want to take up a call, like, like Mohit, before purchasing, because we can understand the value is high of the product.
okay,
So
okay,
before purchasing, if you would like to go for any pilot project, so we can
okay,
connect with them, and
okay,
they come to your site. If it's a job, I can even come along with them. If it's a long,
okay,
then they can maybe I think it can be some chargeable one if it's a long,
okay,
and
okay,
once you are satisfied with the solution, then maybe you can take up a call, like whether you want to go ahead with service or you want to buy the.
okay,
So maybe after this call, if you want, you I'll share my mail ID, sir. Let me know. I can
okay,
even
okay,
connect you
okay.
with one of them.
Just, yeah, yeah. You can share. Thank you, sir. Thank you.
Thank you, sir. So Nikunj, any other is there? Any other question?
Oh, sir, in the chat box, I think so one question was there, but you already covered that also. So
Okay.
now no more question is there.
Okay, so we will, I think, then proceed next. So apart from the one which we have just shown to you, like for the plant and piping, we also have solutions for Revit as well. So when we talk about the as-built offering of Faro, so you can actually convert your scan data into a BIM model directly into your Revit platform. So Faro also offer the plugins which will run on the top of your Revit software and make the 3D modeling much more easier for you. So let's take an example in this case itself, because we have scanning from this apartment from the inside. So as a result, we have scanned both of the surfaces of the wall. Now, in some area, we don't have like both of the surface, but based on the drawings and based on the input from the site, we have considered that, okay, this wall may be 120 mm, the partition wall. But in those area where we do have both side of the wall, we can actually do an automated fitting of the wall itself. So in this case, you can see the walls has been inserted automatically within the thickness of the point cloud data, which has been captured from the site. So the as-built tool means, or when we say the as-built for Revit, is actually offers you the complete semi-automated process for fitting your walls and other elements such as pipe from your MEP needs to be fit in with the point cloud geometry. And at the end of the day, if somebody asks you even for the model accuracy, so you can also run the algorithm, or you can also run the analysis, where you can also submit the report that, okay, this is the model accuracy with respect of my point cloud data. Because in most of the cases, what happened that once you have a 3D model or a planned model and the real construction site, there can be differences or there can be deviation. So those deviation can be easily identified within the construction phase or before handing it over to your customer or to the client. So the construction companies can get really benefited out of it. So that's what we are offering right now for the BIM segment as well. Sorry. Whereas in this example, again, this is one of the facility. This is our own Faro New Delhi office. So where we have scanned near about an area of 8,000 square meter, and the entire facility has been scanned. So we have done the scanning from the outside of the building, and then from the inside, we do have the main office, the Faro office. So to do the same, like we have set up our scanner at multiple positions all around the building and as well as for the inside. And in this image, you can see the scan data. So because we have not scanned from the top, so that's why the top is open. But if you see from the sides, we have covered like most of the areas. And then from the inside, only a single floor has been scanned. Later on, inside the as-built for Revit, we have converted into a 3D model. So all the glass, the curtain walls have been placed from the Revit. We have created like the survey walls, means all kind of edges, detailings have been added inside the Revit itself. So again, all of this thing has been done by the help of this laser scan data. I have not visited to the site. I have not done any manual measurements. Nothing is needed. I just take some scans, come back to my office. Now, if the scan data is not visible, we also have captured the images by the help of same scanner. So the focus laser scanner also have provision for capturing images as well. So we have taken high resolution images, and individually I can review those images in case I want to see some detailing at some particular location. Like in this case, I try to find out like what is the name written on the building. So the Opal Genesis is the building name. So every those sort of detailings has been added manually inside the software itself. In some of the other examples, I think this is one of the projects where we have, I think, collaborated with the Autodesk long time back, and we have done a building scan for them. And later on in their platform, they have converted into a 3D model. They have also created like the facade plans, drawings, sketches, and everything out of this scan data. So again, as I said, like the application point of view, we have a very diverse application. The same device can be used for civil, architecture, forensic, forestry. We also have people from heritage and preservation. We have people from film and movie industry as well, who have been using this laser scanner for creating sets, the virtual set. We have people from plant engineering, surveying, shipping, tunneling, tunnel and mining, gaming, and as well as for the 3D modeling as well. So currently we are not restricted. Again, it totally depends on the user need, because when I talk about the technology, it's only giving you a freedom of choice for documenting your space or documenting your site. Now, how you want to manage that data, it's totally on you, that how you are going to work with it. Okay. So Nikunj, I just want to confirm that I think we have some time left with us.
Sir, till 11:15.
Yeah, till 11:15. Okay, so I have a quick case study, I think, which we have prepared for the construction industry. In fact, this exercise is what we have done with one of the big construction real estate construction company based in New Delhi, and where we have been doing the complete scan to the BIM job, and as well as the construction verification, the QA/QC part for them as well. So the agendas which we do have in this case study is like, introducing the technology, resources which we have used, what are the methods we have followed, the registration workflow, and the construction verification workflow. So if I talk about the initially the workflow which they are looking for, or what we have offered. So we have actually offered them VeroFocus S350 laser scanner. And again, this is needed for doing the documentation part. In fact, as per my experience, I think what I get an input from them is that, like, in most of the construction companies, not specifically to these clients, we came to know that they have been using various other methods, for doing the progressive construction monitoring. Some of them are using the GoPro camera. They mount it on the helmet and take a quick video. And from those video, they actually evaluate that how much construction progress has been made on the site. When we talk about those sort of technologies, they can be useful up to some extent. But when we talk about if you want to go for dimensional checks or maybe some QA/QC part, those are the area where they start lacking, or those technology may not be suitable for them. Then in that case, that's what we have offered. So we have offered them the complete offerings from Fero. That is the VeroFocus 3D laser scanner. And to process the data processing and registration, we have offered them FeroScene. To convert a 3D model, we have offered them as-built suite. So as-built suite consists of as-built modeler, as-built for AutoCAD and Revit. So depending on the user, if they were using AutoCAD, they can use the AutoCAD part. If they want to use the Revit part, they can use the Revit plugins along with their AutoCAD and Revit. And lastly, for the verification part, we have offered them built-in construction software. Now, the scanning method is what we have followed or the workflow is like we start capturing the data. We have done the data collection, then we process the data and register the data. We have exported that entire set of data from our scene software, and we import it inside our built-in construction software. When we have imported, so inside the build it is the main, I would say the main key or the main element where we can perform various tests depending on the site need. Now, in this case, we have done like the wall flatness. We have also checked for the wall plumbness, point cloud versus their 3D model or versus their BIM model. And we have also done for them, before installing the lift shaft, so we have also done the lift shaft analysis in the same case. Now you can imagine with a single data, we are actually doing multiple studies at the same time for the construction site. So if we talk about the bigger picture, that you don't need to actually spend more and more time on different sort of data capturing. Within the one space, one day you can depute a team, they can go to the site, they can do the scanning, come back to you, and you can process the data. The best part is that the data is going to be virtually with you throughout the time, or throughout your construction phase, or even after the construction, you can preserve that data. And if you want to do the comparison, study, anything, they can be done in that phase itself. So if I talk about this one, again, there are some commercial towers. They have 2 commercial towers which are being under construction, which needs to go up to a height of 62nd floor. At the time when we approached them, it was under construction, and they have reached up to like basement 3 level. So they have like 4 basement levels as well. So this commercial tower means what they do have the as-built, not the as-built, they have a 3D drawing or a proposed CAD model. And if any changes needs to be done based on the site input, they do it based on their manual measurements, which has been collected or captured by the data or by the team, or by the help of the video, which they were recording by their helmet cams or any other technology. Now, these are some site images. Now you can see on the top, this is the scan data. So you can see this is my scan position, and this data which you're seeing, it's actually look like an image. In fact, in the bottom, you can see this is the actual image, but this is the laser scan data or the point cloud data. So the data quality is actually pretty good. You can't even compare, means when you see the data from a far distance, you can't even realize that it's basically a point cloud. And once we have done, now the scene software for doing the data processing and registration offers you multiple choices. So a user can actually use the target if they want to stitch the data within the with the precision level. So for the target, they can paste checkerboards. We also have spherical balls or sphere targets, which can be used on the site, and they can be used as a stitching object or a reference point. But apart from that, we also have the automatic registration workflow, where the software will do the automatic registration based on the top view and as well as the cloud to cloud comparison. When we say top view and cloud to cloud, so that actually try to stitch the data with respect of the geometry of the room, or maybe of a building space, or even for the outdoors. So it tried to stitch the elements, like, it tried to take out the largest plane, whichever is common in both of the scan, the side walls, the corners, intersecting points and everything. And then based on that, it do the stitching part. So again, the scene software is intelligent enough to understand all these laser scan data and can offer you a complete automatic 3D registration workflow from the site itself. Now, once we have done, then inside the scene, then we have export. So scene actually offers you multiple format to be exported. So if you want any other specific format as well for some of your own software, such as for Autodesk, we export RCS or RCP file, that is recap scan or recap project file. If you're using any other software, then and you want some inter-exchangeable formats like E57, so that can also be exported. So in this case, what we have done, we have exported .E57, but apart from that, you can export E57, PTS, PTX, XYZ, and so many other formats are there which are available inside the scene software for exporting your data and bringing it inside any other third-party software. In my case, we have been using the same. From Ferrocene, we bring the data inside our built construction software. And inside the built construction, then we have run the testings. That is for the QA/QC part. Now, imagine, this is one of the examples where they do have a finish flat, which is somewhere at 11th floor of the building. And that building is going to be somewhere around, up to like 62 to 65 floor. Now, if there is a, let's say, they do have a balcony area where the drain needs to be at this end. But when we have done the scanning and when we have done the complete laser scanning for the site, what we have noticed that the drain is actually the flow of the balcony is towards the other end, towards the opposite end. So again, this is not the final balcony. So then based on this, they get an input and they can able to treat or rectify this issue so that the water seepage and other issues will not be there when they have the final delivery of the project. So as a result, in the initial stage itself, they can rectify and they can shift the flow of the water, or the flatness of the floor can be shifted or can be rectified in the initial stage itself. Similarly, we do have wall plumbness as well. So instead of using a plumb bob like an old method, or the water level, the water tube leveling, so what they can do, like for this building facade itself, from the ground it may look like, you know, it's completely straight or it's completely plumb, but when we have analyzed the data, then we have seen like this area is having too much distortion. Now this tolerance can be set it up by the user itself. So you can see all these area are like the large lump, or this edge is like the area which is having acceptable limits, but the red areas are the one which are the high points. So in the initial stage, they can cure it, they can rectify it if the builder or the construction company wants to check with the contractor. So he can ensure that before delivering the project from the contractor point of view, he can rectify it and he can make it correct according to his need. So this is another example, like where apart from floor flatness, the wall plumbness can also be checked by the help of laser scan data. Now, the third option is, because they do have a CAD model, so we propose them that, okay, let's have a point cloud versus BIM model comparison. And we have done this thing for two different planes, one with the help of BIM model, and the other is what we have done with the help of the 2D drawings, which they do have on the site. So in my next slide, you will see that we have also done the comparison with respect of the 2D drawings, and we have actually seen the differences from the site itself. So if you see in this case, like we have converted, we have superimposed the CAD model on the top of our laser scan data within the, or by the help of our built-in construction software. And once we have done, now you can see these color codes, which will show you that, you know, what are the in points, what are the out points. Because again, this is from the real data which they have extracted and the as-built information. That's why it's having very less noises or very less like the incorrect tolerances. And the red areas are only the one which you can see. These are the debris which has been formed on the surface, which may be removed after the finalization of the project. So again, this can be a quick tool for getting your, like, you know, the complete construction progress to be monitored, and you can keep an eye on the same itself. Here are some of the outputs which has been generated from the scene. So now you can see, I can ensure the column placement. I can see the column placement wherever the columns are. These blue points are the one where I have kept my scanner. This is the scan data which we have captured on the site image. And even from the image itself, I can also do the measurements. So let's say I want to see the balcony to balcony distance for each and every balcony. So I can also pick those points and I can do it from the scan data. And this sort of viewer can be generated. So later on, you can share this viewer to your customer or to your project manager or anyone, and they can understand that how the site looks like. As I mentioned that we have also done a 2D comparison. So in this case, you can see this lightish gray or the transparent data is the scan data, whereas these red lines are the 2D drawings which they have supplied us. Now in this area, we have seen that without documenting, they actually has changed the size of one of the washrooms or the bathrooms area. And when they noticed this, so they realized that yes, the laser scanner can actually be beneficial for them for their day-to-day needs. Similarly, for this part, means we have tried to figure out the beams and the deviation in the beams from the 2D drawing itself inside the AutoCAD software. Apart from that, the same example we have done for them. So as I was mentioning, for the thickness of the wall, software is intelligent enough to detect the thickness, and based on the detection, it will suggest to you that which type of wall can be used, whether it's a Surveyor 300 or maybe partition wall 120 or any other type of wall. So then I can say like, yes, choose this one, and I can place it accordingly with the adjustment or without adjustment, because sometimes it happened that, you know, the wall size may not be as per the library or as per the family of Revit. So we also have an option where I can say insert selected object with the adjustment. So as a result, the same wall, which earlier was of 300 mm, based on my point cloud data where it shows it's of 450. So the same type of wall will be adjusted to 450 mm. Okay. So now it's an easier job for you to compare or to convert it from scan to BIM model. Similarly, means we have done this exercise for them as well. So for one of their studio flats, and they do have like a multi-story studio flat. So for the they have 4 floors. So from the bottom floor, actually, where the lift needs to be installed, we have taken a scan, and these 4 floors actually have been scanned by the help of Fero laser scan data. Now you can see we can actually measure the gate size, and we can also ensure whether the shaft is completely plumbed or not, so that tomorrow when the lift cart needs to be installed, so that cart will not be colliding with the surfaces, and they can do the installation of the lift within the time period without any delays. So before doing the installation, they can actually run the simulation part inside the software itself, and they can see that what are the high points, what are the low points, which can affect the shaft or not. So they can also define the tolerance, and they can have this sort of report where they can see the surface deviation analysis and the values for each and every points. If I want to annotate points which are beyond the tolerance, we can also do that. And all those points will be marked out like in this sort of thing, and we get a complete brief report for those specific points as well. And then last but not the least, so now in this case, you can see we have also done the annotation. So the average out points and the in points we have marked out on the drawing itself. So now in this one, we only see the major issues with the debris itself, but the rest of the data is actually within their tolerance level. And now in this one, as I mentioned, that this is for the balcony area where the floor flatness needs to be done, and we have done it with this. And then the wall plumbness example. Okay, so by the help of this, actually means what they find out is that, like, you know, the documenting of the site is very much easier. The workflow for maintaining the QA/QC can be easier by the help of this. And this technology can be helpful not only for like, you know, documenting one-time site information, but forever, means they will be having a digitally preserved data for each and every site. Now, their data can be used for maybe, let's say, for the 3D modeling, as-built BIM comparison. If they even want to use it for the marketing and video presentation part, they can also use it. We also have features where you can also see the entire set of same point cloud data into your VR, into your virtual reality headset. And in fact, that is what we have also offered to IIT Palakkad as a part of their package, which we have supplied earlier. So they do have the complete scanning software and as well as the VR headset. So they can plug in their VR and they can see the entire site by sitting in their office. And they can review, they can do the markups, they can do the measurements and everything on the go. Okay. So I think that's what I do have from my side. In case you guys wants to go for the quick idea about the hardware, software, and other tech sheets information related to Fero. So we do have a dedicated website, that is feroKnowledgebase.com, or you can simply visit knowledge.fero.com on Google, and you can have the information related to the tech sheets, the hardwares, the softwares, and related videos of the same. Okay, so I think that's it from my side. In case you have any queries, we are open now for QA/QC. Sorry, QC, not QC, for the QA. And for any questions, if you have any specific question related to Fero, or if you want to see the demonstration on site, you can get in touch with us, and I can answer you, or I can connect you with the right team to get all your queries to be answered.
Thank you, Moisa, for your knowledgeable session. You had broadly covered that how this all Fero product can be useful as a key tool to digitalize our AEC industry as well as public safety and metrology sectors. So it's good to hear from you these all keywords. So thank you very much, sir. Now we are not taking that much time to take a question and answer from the audience. So I'll request to the audience to drop a mail that already provided here, and we'll go further with our next speaker. Thank you, Mohit sir.
Sure, Nikunj. Thank you. Good to be with you guys. And thank you everybody for listening. And thank you, Senthil sir, for giving us the opportunity. And yeah, that's it from my side. Thank you.
Thank you, sir.
Good morning, participants. As this takes a bit long, we are continuing with our section. I would like to introduce the next speaker of this section, Mr. Sushil Kumar. Mr. Sushil Kumar is a faculty member in Department of Building Engineering and Management at School of Planning and Architecture, New Delhi, an institute of national importance. He is graduated from Madhav Institute of Technology and Science, Madhya Pradesh, in architecture, and continued his post-graduation in Building Engineering and Management from School of Architecture and Planning and Architecture, Delhi. And he is currently pursuing his PhD in Building Rehabilitation and Retrofitting. He is a dedicated teacher and a keen researcher for the past 8 years. Before joining an academy at School of Planning and Architecture, he worked with various multinational companies as a design manager to execute different high-end projects in India. He has lectured extensively on building management all over the world and has many research papers in national, international, and conference to his credits. His papers appeared in the publications like RS Press, Sprinkler Internationals, and other peer-reviewed journals. Some major events organized by Mr. Sushil are Real Estate Project Management Workshop 2019 and 2020 in collaboration with the Ministry of Communication, Government of India, and National Student Design Competition on Universal Design 2013 in collaboration with Archaeological Survey of India, and Inclusive Design Studio under Berkeley, the Teaching Fellowship 2013. Other than his regular teaching and research at School of Planning and Architecture, Sushil has a member of various national and international academic panel and reviewing research papers of many renowned journals. He is also a member of various consulting and research projects funded by Government of India. It is my great pleasure to give an introduction to such a great speaker of this section. I'm handing over the platform to Mr. Sushil. Thank you, sir.
Thank you so much. Thank you for the introduction. And a very good morning, all of you. I'm sharing my screen, presentation screen. Okay. I'm Sushil Kumar Solanki, Associate Professor at School of Planning and Architecture. I'm teaching post-graduation graduate students over there. And all the information has already been given by the organizer. So today I'm going to present an important topic, that is building rehabilitation. It's a management of building rehabilitation through BEAM. We have been working in this sector from last around 10 years, and many case studies we have already been done. Various projects where we have already been built at various stages. I mean, we have also dealt projects which are being constructed by Government of India, state governments, or many other. The first of all, I'll just introduce what is building rehabilitation and why it is important and why we people are working relentlessly in this sector, because sustainability is the first criteria what we have actually identified over there, because it's avoid creation of waste and all. After independence, we have created or we have constructed many buildings, lots of buildings we have constructed. Yeah. And now we are actually watching that many buildings are now in deterioration condition because of many reasons, maybe chloride attack, or maybe carbonation, or maybe many things are there, many root causes are there. So now people and many agencies, what they are doing, they are either demolishing it and they are reconstructing it. And many people, what they exactly want, they want to create a newer kind of impression of the building, or maybe the newer FAR could come and then they will want to enhance these spaces over there or enhance the functionality over there.
But what we have identified that by demolishing the structure, we generally create the waste, and that waste will not be recyclable. I mean, many researchers and many organizations are working very relentlessly to reuse the waste and all. But many times we understand the situation that waste is not being recycled and affecting our environment. So the moment if we will be going for the building rehabilitation, certainly it avoid the creation of waste, and then we can generate or we can save our environment. Consumption of large scale of natural materials, certainly the moment you will demolish the structure and you will redesign and reconstruct the building, then you will procure material from the national boundaries or maybe the international boundaries. And the moment you will be procuring the material from a n number of places, certainly the environment will affect because the transportation and its pollution, and then the cost will also be very at the large scale. So the rehabilitation and sustainability complement each other. I mean, if anybody is talking about the saving, energy saving, or maybe uh, embodied energy, or maybe a number of saving on the energy level, then we can say that if we can rehabilitate the building or the old building and we can customize it, or maybe we can enhance these spaces, enhance its beauty, then certainly we can save the environment and we can save the energy. And we can say that it could be a alternative to the it is a complement. It complement as a sustainable. Now, what is rehabilitation? What is renovation? And what is restoration? Rehabilitation may include replacement or strengthening of deficient or damaged structure. So you cannot say that you will be a I mean, you will be again taking the building to the original shape, or maybe you will be going for extraordinary upgradation and all. Yes, you can repair the structure and it can take the existing load and it can work properly. The operation could work properly. Repair of leaks and damage to roof and exterior walls, windows and doors are also typically included over. Sometimes we can replace the walls by efficient walls. Sometimes we are replacing the windows and doors and all, because these are these are the material which has already been deteriorated and all. So sometimes we can have a replacement, but many a times we go for the repairing and all. The building system are brought into general conformance with the local codes and ordinances. So the moment we'll go for the rehabilitation, we are uh, uh, trying to adopt the local building bylaws, building laws over there, and then IS codes, and also so when the moment will upgrade or we will go for the rehabilitation, our building will be very near to the upgraded kind of building, or maybe the newer kind of. But on the contrary, renovation, I mean, renovation is not very far from the rehabilitation, but you can say the new building within the framework of old one. That means a very newer kind of structure, I mean, internal structural system, or you can say the functional elements could be adopted over there. Typically meets new building code requirements. So suppose if renovation will be taken place, in that case, we will be going for the upgraded kind of IS codes, or you can say the building bylaw. But in the restoration projects attempts to restore a building to its original condition or to its condition at a certain day. So if you can say the fort and palaces are being now renovated or rehabilitated, that is actually a restoration kind of thing. So the older one can be restored at proper level. So an example of restoration is colonial places which has been reconstructed to a specific era in the town history. Now, the biggest challenge in the building rehabilitation project is your service life prediction, or you can say that service life evolution. Uh, like as I said, that after independence, many countries, many projects has been constructed in India, and many buildings has been designed by taking example of like colonial impression or maybe the Mughal impression and all, and then buildings have been created and all. Now in Delhi, if you can see, the lots of building has been constructed after independence and for the government uh, offices and government. After 40, 50 year, if I mean, earlier we were assuming that 50 year or 60 year is the age of that particular building, and now at this stage, if we want to assess that whether this building is working properly or whether this building works in the upcoming year or not, then understanding the service life and prediction of the service life, it actually defines the period of time in which a building can be used, can help to decide activity required to maintain, repair, and service. So if we can say a building which is at the exterior level, a building is not looking fine, or you can say the impression is not good of the building, it doesn't mean that the service life of building has already been over. So the understanding this service life is always important, and it depends upon the various factors, that what is the purpose of building, what is the construction material has been adopted over execution of construction, what is the method of the execution over there, surrounding environment and time span of maintenance. Suppose a building in Delhi, if you can say that a client would come to us, and then if you would ask us, okay, we want to rehabilitate the building, it is in the impression that it will collapse, or it can get collapse at any day. So then what would be the next step over there? And then people will go there, and we as an academician and the professional will go there, and then we'll evaluate that what is the service life of the building. And if we find that, if we'll find that, I mean, still it works for next 10 years or 15 years, because it has all those kind of strength which were actually assuming at the initial level of execution, then we can say, okay, this works for the next year. Now we want to only go for the superficial kind of repair work or maintenance over there. And then next 15 year will be saving for us. Generally, building service life will be categorized into the three sections, that is physical service life, functional service life, and economic service. On the physical service life, that means at what time that column and the beam will work, at what time this particular slab level will work. The functional service life, it's the internal functional service life. That means if we would have a HVAC system, if we would have any kind of firefighting system, and any other interior fit out system, it's what would be the service life of it. And then economic service life is when it will be a cost effective kind of building. So in that case, generally people and client, the moment client would come to us, a client would come to any consultant, they would ask for the rehabilitation, or they would ask for the restoration or maybe renovation of the particular building. Then certainly the first stage is this prediction of or identification of the service life of that particular building. That actually gives us the clue that whether we should go for the rehabilitation or whether we should go for the demolition of that particular building. The service life prediction would have a number of, various models. We could have the scientific model like deterministic model, vector models, engineering models, and all. And we have very good researchers on all those models. I mean, we have n number of journals, n number of papers available by which we can understand what is the linear regression model or the multiple regression analysis for the identification of the service. But the most biggest problem what we are facing nowadays is the movement will get these kind of data, and the biggest problem is identification of that particular building structure or that particular level of structure, and then collecting the data, because the moment you go for the building rehabilitation kind of project, the collecting data from the building is very difficult, because as an architect, if I could tell you that the moment we'll go for the rehabilitation project and all, we could not find the drawings which has already been uh, designed earlier and which has been constructed and which has been executed in the building. So extracting those kind of information is very, very difficult. And the moment if you could not find the data, these models will not work properly. I mean, these models, certainly if you could have data and if you feed into these models, it gives you a very realistic. So many a times what we are doing, we are using factor methods, and because it gives us superficial and it doesn't give us a very detailed kind of calculating kind of results. So what we exactly do, we generally go for the factor method, and we are actually calculating the estimated service life of the particular component, and we are identifying through material design factor, internal environment factor. But it is not lab tested kind of thing, and you cannot say that every aggregate or every concrete area will be generally evaluated, and it generally gives us the impression that it works for next 50 year or it works for next 10 years. uh, so decision factors of the building rehabilitation depends upon the uh, um, various components, and you can say that what are the decision criteria which supports owner to select the rehabilitation over new construction is actually various stakeholders actually decides how a building rehabilitation could be done or how a project will be successful. So major stakeholders generally involved in the decision making of for rehabilitation is the building owner, building user, tenant, government organization, municipal bodies, investor or financer, or many organizations and all. Now, the moment you will go for the decision on the building rehabilitation, whether we should go for the rehabilitation or whether we should go for the newer construction, uh, as I said, the data is very, very important. But nowadays, every client would ask us if we are going for the rehabilitation project and if we are going for the newer kind of project, what could be the cost benefit over there? Which one give us a good cost? Because now money make. I mean, every time if you'll just put a money over the any project, what would be the return on that? That is the major people are actually worried about all those things. So I'll just show one case what we have done in one rehabilitation project in New Delhi. It's a IMA building. The construction period was actually 1965, and the client would come to us in 2009 for the rehabilitating the building, because earlier the building was when we have not seen the building earlier, and before that uh, uh, and we have not actually rehabilitated the building. Before that, the building was uh, under the distress over there, and many seepages were there. The elevation was also updated, and many problems were there. So in 2009, they actually uh, requested for the rehabilitation project, and the structure is actually a frame structure. Foundation is actually isolated foundation. Number of stories is D+5. Dimension is around 31 by 30 meters. And deterioration was actually visible at that time. But as I said, that the visibility can't actually evaluate the entire distress in the project. So we actually investigated in very detail over there. We went for many tests over there. The client was asking us that whether what would be the actual benefits of those rehabilitation, that particular rehabilitation to that particular project. Because now, if you can see the in New Delhi, if you could have a newer kind of project and a very high-rise structure, the moment you would have a very good FAR, you can give it to the various tenants. I mean, people could borrow it, or people could actually rent it for the high amount, and then and the client could actually generate a good amount of revenue out of it. We were actually first we have actually visually inspected the building, and then we have tested it through various means, by various non-destructive tests we have conducted over there. The facades and the internal beams and the various dampness was there. But actually, like I said, the uh, next level of decision could take place only client could understand that this rehabilitation project will be benefiting to them or not, or they should demolish it, or they should rebuild the entire building. So what we have done actually, we have actually first of all we have calculated and we have done a very comprehensive study on that. We have tested through various means like non-destructive tests we have conducted over there, and we have identified that now the 16.8 or around 17 years are left for the next service life of that particular. That means if we cannot rehabilitate it for a larger level, it will only retain it. We can retain it to the next 16, 15 year to the particular building, and that doesn't give us a very true picture that during the operation it will not fall down, or the internal structure will not be collapsed. So we have adopted BIM and we have adopted Revit on that particular project. What we have done, we have actually created existing model on BIM, and each and every component, each and every structure, we were trying to build it on, designed it on Revit. Internal HVAC component, everything we were trying to build it on, we were making on Revit. On the contrary, we have also designed the newer one. What could be the potential future project over there by adopting the existing or newer codes, newer IS codes, newer building bylaws, and newer FAR we are getting over. And then we were trying to actually compare both the models, so we can actually give the impression, or we can give the entire data to the client that which will be benefiting to them and which will be benefiting to environment. So we have started taking direct and indirect cost of rehabilitation, and direct cost we were actually because BIM was actually giving us a true picture. Certainly, you cannot get each and everything if you don't have older drawings or an older documentation of it. You get each and every inch of detail. But yes, we were trying to through various scanning also, various surveys also. We were trying to get each and every data of that particular building, and we were transforming those data into the Revit structure. The moment it will transform into the Revit structure, we were actually getting the existing situation, and then the moment with getting the existing situation, its structural system and its structural behavior could also be judged. And then if any column will be require jacketing or any other treatment, what would be the cost of that treatment that we have actually assessed. So through direct cost, the construction cost and its consultancy cost and its legal cost has been assessed. And we have cumulatively identified what the cost of the direct cost of it. Indirect cost we have also assessed through BIM, which is actually a service and utility like water, insurance, overheads, labor, and work. And through this, we have actually added it to the entire costing system, like direct and indirect cost will give us a true picture of what would be the cost of that particular unit. But on the contrary, what one exercise we have also done, where we have again calculated the service life of the building, and we have proposed that next 25 years should be, next 25 years should be the service life of the building. Maybe it could be 40 or 50 year, but it doesn't give us permit. That existing structure was not giving us the permission that we can exceed that service life of the building, because we had too many restriction of the older structure and older system. The many tangible and intangible benefits we were getting, like no disruption in rent, because right now there are rented space. Many government agencies and private agencies have also taken those spaces on rent. So the client were getting good amount of revenue also. If we could demolish that structure and we could, if we could rebuild the structure, it takes a good amount of time. In that case, rent or the revenue could be there could be loss of revenue. Reduction in O and M, that operation and maintenance is also uh, uh, reduced over there. You can reduce it. You can go for this kind of area. Increasing durability of structural life, prevention of structural failure, value of building. These kind of things we are getting through tangible benefits, rehabilitation. Intangible, like prominent public building, because in Delhi, if you can go around and if you can find, and if you can ask anyone where is that particular place, and that is actually every building is landmark over there, and you can have, you can demolish that particular building, and so it's actually historic value, or the older value will get also wasted. So prominent public building, its impression could also be saved in intangible ways. Sentiments of association, example of the other public buildings and better environment for occupants, benefiting the intangible benefits. We actually calculated through BIM, we have calculated the support items, demolition, MEP works, finishing and all. And each and every cost we have calculated. Barricading, scaffolding, centering and shuttering. Through demolition, if we can demolish some part of the structure and then we can rebuild, what would be the cost of that? That we have also tried to figure out over there. And then MEP works and things. So around 2 crore uh, cost we were actually we have figured out through for the direct cost. Uh, Calculating actual cost of revelation, if you can say over here, is actually we were actually trying to identify that if we can rehabilitate it, so we can rehabilitate it into various parts also. And if you can rehabilitate various parts, so one area could be, I mean, vacant, and suppose one rented space could be at that particular time could be used for the rehabilitation. So the part-wise part, if we can rehabilitate the building, so lesser amount or lesser work destruction could take. Labor insurance and site overheads could be used. So indirect cost is was also calculated over there through BIM. Uh, so this is how we have actually calculated the direct revenue reduction in OM, increased value of building, increase in durability and structural value. So larger tangible benefits we were getting through this rehabilitation, and then we were trying to identify what is the actual cost of that particular building. So around 2.7 crore were actual treatment over there for the rehabilitation. Now we actually, like I said, we were trying to extend it for the service life could be enhanced till the next 25 years. We were trying to identify what would be the net present value or what would be the benefit out of it. So if we were putting it to the various cash flow, and if we were trying to put into the cash flow and net cash flow and net cash inflows and outflows we have generated over there, and we have find out that if we can rehabilitate that particular building, and the internal spaces could be in the good space could be generated, and we could generate good interior also, good service packages also over there, then around 203% of IRR we could get over there, and only 1.35 years would be the payback period. If you could take the 8% of discount rate of discount rate when we are calculating the entire financial that particular financial system. So the good NPV we were getting around and around 147% of net profit we were getting out of this rehabilitation. Now the next is your newer construction. Like I said, the on building information, like BIM model. Through Revit, we were trying to generate a model which is for the newer construction, a newer kind of building. If you could demolish the structure and if you could design the newer construction, what would be the benefit out of it, and what would be the direct and indirect cost should be there. That we were trying to also assess, and that we want to project in front of the client also. So direct cost is certainly the civil cost, and the demolition cost also comes under it because the existing structure has to be demolished. Consultancy cost and the legal cost, and then your indirect cost like service and utility, insurance, overhead, labor, works. But here a larger loss is your rental disruption, loss of revenue, because if we will be going to construct that particular building, around 2 years will be the minimum construction period, because you have to demolish it and you have to rebuild it. And then if it is in the very core of the city, then certainly the transportation is always a bigger challenge for us. The transportation of concrete, transportation of various material is very, very difficult in the case of large cosmopolitans. Shifting the cost, newer rental costs, and hauling the cost. I mean, if you can start constructing the newer building, then you have to shift the present office and you have to rent the space of another building also, and you have to pay the revenue rather you were generating earlier you were generating revenue out of your food. So benefits, we were getting good amount of benefit, like if we can construct the newer building, you will get a good amount of FAR. You can go for the high-rise building. You can earn good revenue out of it also. And newer symbol you can generate. A value of building could be a good benefit out of it. But the biggest benefit what we could get is a next level of service life, that means in next 50 or 60 years. You can go for the newer. So we have assessed that what would be the FAR. The current FAR is around 1 or 1.5. Like can go for the next level around 3 FAR. Good ground coverage, good built-up area you will get. So a good benefit certainly you will get, but the larger level of newer construction material you will require over there. Demolition cost will also. So we have calculated the indirect cost and direct cost over there. Like I said, the various benefits we were getting indirect cost. So tangible benefits what we were getting is increase in the rental revenue, reduction in O&M cost, value of building, and risk mitigation. But everything what we were actually trying to, I mean, the data what we have generated every time was on Revit. Each and everything we have calculated minutely. Each and every services we have calculated minutely. We have not assumed anything unnecessary. Now, if you can compare it with the like the earlier cash flow we have generated and the current cash flow what I am showing over here. The earlier internal rate of return, that IRR we were getting around 203% over there. Good net profit we were getting. Payback period was also 1 point. On the contrary, on the newer construction, if you will be going, the internal rate of return is only 10%. That means the payback period is also very high, 9.5. But certainly, the rather than 25 year of service life, we are now getting 50 year or 60 year of. But if a client is asking us, if client is actually asking us what will be the benefit of the rehabilitation and newer construction, certainly it gives us a picture that we should go for the rehabilitation of the building rather than going for the newer construction. Next 25 year or next 20 year will be easily you can operate that particular building, and then after that, if you can go for the renovation of that building, then I think that would have a good background of or good justification over the. So the comparison what we have done over there, the rehabilitation, actually your EA what we are getting over there is larger EA we are getting. NPV, the net present value, we were getting higher in the rehabilitation also, rather than in the going for the newer car. IRR certainly rate of return in the rehabilitation project, because the moment you will be rehabilitate it and then you will increase your rent over there, and then revenue will be on the higher level, then certainly you will be getting good amount of that. 203% of IRR and 1.35 year of internal rate of return will always be benefiting to you. That's how we actually convince our client for the rehabilitation of that particular building. But the only background or it could happen only because we were actually getting a good amount or good software. Every time we were actually evaluating each and every component, every space, and then we were actually trying to make it on the Revit. And then we have assessed. So each and every space, each and every component was very well assessed and very well taken out for the understanding the cost on it. And then indirect and direct costing and its cash flow analysis has actually given us a true picture, and then we had actually projected. So certainly environment impact will be also there on the regulation that could also be assessed within. But costing over here, which is major worriness from the client side, and many clients and many organizations or government organizations actually they are actually targeting the cost rather than other things. That gives us a good justification. So certainly rehabilitation project is always gives you benefit. It always gives you a momental benefit in terms of economy. You can save money also. You can save the moment. You can save the various other you can get various benefits. So that's how we can if you can evaluate the building, if we can have a good tool to evaluate the building, whether we should go for evaluation or rehabilitation, or whether we should go for the newer kind of construction. That's how if we could generate our model on various softwares and we can evaluate it, and then we can have very scientific model. Then we can have a good information and we can show it to the client also, various government agencies also, that don't demolish it, try to rehabilitate it. It works for this in some years. Thank you so much.
Thank you so much, sir, for this wonderful knowledgeable session. So now if participants are having any question, then they will also put in the chat books or also raise their hand so we can unmute them.
All right, Nikun, then
yes, sir.
Anything would be there, please forward that.
Okay, sir. So right now I don't think so any more question is there. So, sir, can we wait for 2 or 3 more minutes?
Good morning, sir. Is it audible, sir?
Yes, yes.
Yeah. So in the cost benefit analysis, so what are the intangible benefits that you considered? Like not
Intangible benefits in the newer construction or older construction? I mean, the current existing structure.
Existing structures.
See, in the existing structure, what we have intangible benefits, what we were getting actually if we have like in the core of the city, if you have any building, it would have certain impression of historic, impact. And then you have certain social connects also. And the people are actually, if you are traveling to any city, even in Delhi or in Mumbai, you always in the impression, you also have in the impression that that kind of building or that kind of structure I can see over there. You can travel to Barakamba Road in the Delhi, you have always impression that these kind of structures are there, and that those kind of intangible benefits are always, we are always carrying, intangible things impression we are always carrying with us. So if you can save those kind of structures, if you can go to Mumbai, the VT could be there, and then you can go to Delhi, the Connaught Place and all. Those structures are also, I mean, those are, you are also in the impression that those structures will be there, and those kind of intangible benefits. But many more intangible benefits we were also getting over there, that social connects, and then the internet blessings are also, were also.
What are the tools it's available for the rehabilitation of these kind of existing structures?
Tools for
Uh, in your case study,
hmm.
so you just benefit analysis you made. Yeah, so any software tools, I something like that. So we have so many historical buildings. General question I'm asking actually. So historical buildings are something like that for the future for the development process. So it's very difficult. It's costly also to make use of these laser scans and something other things. So what is the other opportunities? So
Yes.
yeah.
So exactly what we are doing, as you like you said, the laser and the various other technologies are also available, but those are very expensive. I mean, you cannot anytime you cannot procure it, and you cannot use it. If you can use it, then certainly consultancy costs and its operation costs. What we have done, we have used multiple softwares and multiple systems we have like we have tested on, we have actually collected the NDTs, we have gone for the uh, visual inspection, we have collected data physically also. Then we have taken various images, and we have transformed those images into the these, softwares. Uh, each and every identification of each and every system is sometimes is not possible, but what we have done, we have actually documented the building physically. I mean, we were actually physically present over there, and each and every inch we were trying to calculate it through lasers, I mean lasers, through various measurement techniques and all. But certainly we have not, I mean, at that time the laser was not our the laser scanning was not available for us. So what we have done, we have used Revit model over there. Every time whatever we are actually measuring, or every time if we are making any drawing, any document over there, we were trying to transform into the Revit model, and different components of Revit model we have actually generated. So we have actually converted the entire building into various zones. So first zone, if you are evaluating or if you are assessing the first zone, that particular assessing the first zone, that details we were actually making over there, and then we over there only we are transforming into the Revit platform, and then that's how we actually I mean added each and every zone to a single component, and that single model has given us the true picture of the particular rehabilitation, or the costing of that particular building. So each and every component on the Revit were not possible without physical measurement techniques. But I'm not denying that newer kind of technology could not do it. Certainly, sometimes it does in the proper manner. It does in the very good manner. But certainly, those adopting those technologies sometimes is very expensive and very difficult to procure for every project.
Yeah, thank you, sir. So for I think if you use in a Revit model, we need to create families. The components which are not available, that is also hectic and time
But
consuming
now,
process.
since many people and very many organizations are using it, families could be available very well. I mean, you could find a number of families, but yes, certainly, if you have a very typical project, and every project would have typical so creation of family is not any problem in the Revit and all. People are aware about the Revit and various different BIM model in software. Then creation of family is very easy nowadays. And if you have a typical project, then certainly you have to create the family.
Thank you very much, sir.
Participants, if you have any more questions, you can post either in the chat box or you can unmute yourself and ask to the speaker right now. So we can wait for 2 to 3 minutes, sir, for further questions. Okay, thank you so much, sir. I think we don't have no more questions from the chat box from participant side. So kindly, this is a very informative section regarding the management of information building rehabilitation through building information modeling platform. And we are very happy for having you today for this particular section. Thank you so much for sharing your information and ideas. Thank you so much, sir.
Thank you. Thank you, sir. Thank you, Dr.
Okay, good afternoon all. Can you hear me, all of you?
Yes, sir.
Okay, right. Good afternoon and welcome to this fourth day, third session. We have a wonderful speaker, researcher today for this particular session, Dr. Ranjit K. Soman. Welcome you, sir. And we are happy to have you here. And we are very much keen to listen to your insightful presentation in the prefabricated and pre-engineered structures and buildings and the related technologies. Yeah. And before you start your presentation, I would like to give a brief about Dr. Ranjit K. Soman. Ranjit is a research associate at Center for Systems Engineering and Innovation, and is also working on an Innovate UK funded research project with Imperial College London, and he's also has a multidisciplinary background with strong experience in civil engineering, construction management, metro rail construction, automation, and robotics in construction, virtual reality, augmented reality, building information modeling, wireless sensor network, and automated construction progress monitoring. Ranjit PhD research was done in collaboration with Bentley System, and it focused on automating look-ahead schedule generation using linked data-based constraint checking for construction project. Prior to joining Imperial College, Ranjit has obtained his BTech degree honors in civil engineering from University of Calicut, and his MS is by research in building technology and construction management from Indian Institute of Technology, Madras. Ranjit's area of interest are automation and robotics in construction, IT application in construction management, building information modeling, VR and AR, image processing for construction related problem, system identification, information theory, and sensor assisted simulation. And he has done a lot of international conference as well as journal publications. And I'm again privileged to have you here, sir, for this particular session, and welcoming you again once more. Some of the housekeeping instructions, all the participants, please mute your mic. In case if Ranjit, you feel that somebody's mic is on, you have an option to mute all in your window. You can mute all and then unmute yourself and continue your session. And thank you so much again. Floor is yours. Thank you. Go ahead.
Thank you, Dr. Senthil, for the introduction. And today we will be discussing about modular and industrial construction. So I will try to share my screen now. Let me know if you could see it.
Yes, we could see that. Yeah.
Okay. So again, huge thanks to Dr. Senthil and team for inviting me for this presentation in this program. And from what I saw at like the list of presentation, I realized that most of the presentations were about building information modeling, digital trends, etc. And this presentation might be a little off track, but I would like you to know that this is equally important, and it uses a lot of digital technologies for achieving what industrial construction is. So just to start out with a brief introduction of industrial construction, it is a method that borrows concepts related to manufacturing sector's production process and follows a design, manufacture, assemble, in contrast with a traditional design, construct, operate approach followed in AEC sector. So we would get into it more, but just as an intro, I said that. And moving on to the presentation, most of what we would be discussing today is about why we should industrialize construction, what are the manufacturing paradigms, and how that contributes to how we can draw parallels within manufacturing paradigms and construction. Going on to industrial construction, then we have a little bit of a discussion on projects, process, and platforms. Finally, on to the most aligned part of the presentation with this program, that is digital configurators, and finally on to the conclusions. So before going into the presentation, I would just like to say where I'm from. So I'm a research associate at Imperial College London, which is a science, technology, engineering, and medicine and business university in UK. We are in the top of the rankings in most of the rankings within 10, and like it's one of the universities with the highest impact on research in UK. And particularly, I come from the Center for Systems Engineering and Innovation within Imperial College London. And the idea about the center is to bring systems engineering approaches into civil infrastructure so that we could maximize resilience, safety, and sustainability in the infrastructure sector. So center has mainly two themes. One is on transforming construction, and the second one is on the move towards net zero pollution in the infrastructure sector. And we have 4 verticals to achieve that. One is looking at the complexity and resilience in the construction, looking at the infrastructure life cycles, looking at systems integration and leadership, and finally on data-driven systems engineering. And all of these approaches, when we are looking at infrastructure, we'll be greatly dealing with a lot of subsystems and systems, which is like buildings, etc. And it's connected through digital means and digital twins. So there's a great kind of potential on applying this idea about systems engineering and interfaces into this large spectrum of digital methods. Going on further, so basically these are the kind of like 6 areas that we are pioneering the research at Imperial, which is on complexity and resilience, systems integration, data-driven systems engineering, and the other one is on transforming construction, infrastructure lifecycle, and net zero pollution. And all of this you could find it online in our website. Just Google for Center for Systems Engineering and Innovation at Imperial College London. Also, before going into the presentation, I would like to give my acknowledgement to Professor Jennifer White, who was also my PhD supervisor, and Professor Daniel Hall, Assistant Professor of Innovative and Industrial Construction at ETH Zurich. So I have borrowed a lot and learned a lot from these two professors' presentations and interactions with them. I would also like to give my thanks to Langerook and Maze, who are two big construction contractors in UK, who has got industrialized construction factories. Also to Bryden Wood, who is kind of like a consultant who has done a lot of work on industrialized construction in the realm of digital construction. Soil Built Construction Group in Singapore, who again has got workflows, etc., from which I learned a lot from. Then on Industrialized Construction Forum, which is kind of like a industry academic collaboration led by Stanford University, and they have annual industrialized construction forums where industry shares the best practices, interacts with academics, and forms a joint kind of agenda. Then last on to transforming construction network plus. So this is a industry academic initiative within UK, spearheaded by the UK government. So having said that, I would just ask you to try out this. So mostly during my presentation, especially in this online world, what I try to do is like try to get audience's feedback, and it's easier to visualize it within the presentation. So I use this tool called Mentimeter. So what it does is what you have to do is just go to www.menti.com and key in this code. So all the questions that I'm trying to state within the presentations comes on your mobile or computer screen, and whatever you feed in comes into my screen, which I'm sharing in the presentation. So I have always found this as a really interesting tool to interact with. It gives us a good visualization of the results really fast. So I would encourage you to use this in the presentation. So all you need to do is like on your phone or on your computer, just go to www.menti.com and key in this code. So it will take you to the questions that I have. So if any of you have already done that, you might see a question on how traditional construction is different from manufacturing. You need not answer it now. There would be a time when I would ask you to answer it. So you could do it now, but it's better that if you do it later. But the idea is just go on to the site, key in this code, so we'll have a better interaction. Now, going on to why should we industrialize construction? Senthil, I'm assuming I can't see myself on my computer, so I'm assuming you can hear all right.
Yes, we are hearing you, and we are seeing you, and we are seeing your presentation. All good.
Okay, all good.
Go ahead.
Great. Yeah. So when we look at the present construction scene, what we could see is like most of the construction projects are unique. That means like every time we are creating a new project with a new set of people, and then we are creating a technical solution that is the design and executing it, everything in a one-off way. And there are some construction where it is like repetitive, such as like metro rail construction, when there's a kind of like a process and kind of like a technical system that gets repeated. But if you look at like majority of construction, we are not doing it like that. And what that means is our industry is building a prototype every time. So if you look at other industries, they're actually building a prototype, improving it, and making it a product. And then the product is what gets into the mass market. Whereas in our industry, that is the construction sector, what we see is like every time it's a new project team coming out with a new technical solution. And in the end, it is basically building a new prototype, and this process is fragmented, and it has many actors and interfaces that are not optimized. And the problem with this approach is there is little learning between projects. So every project is unique, and it's only little learning that is transferred between the projects. And this learning is transferred through the people working in the project. So it's basically the people who are in the project gaining some experience, going on to the next project, giving that experience to the next project, etc. So that is a good approach. But what happens is like, do we get to transfer all the people from the first project to the next project for that project to work again? but that's not happening. So we have first project, then we are going into the next project. Some of the people might be retained, but some might not. Then the other people had to be trained on this processes and stuff in the project, and then the project has to be executed. And there's a lot of transactional cost within that process, and it is causing some of the projects to get delayed because there's a lot of like learning curve at the start of the project. So can we remove it? That's the first question. Going on to the second question. Have we got these? I'll be listing out some point. Have we got healthy working conditions in construction sector? I would say not, because if you look at the statistics, 1 in 5 deaths among the US workers is in construction industry, of which around falls account for the 33% of construction death. And what they've told us, like, if you could eliminate the falls, you could actually save more than 300 lives every year. Further, the injury rates in construction are around 71% higher than injury rates across all industries on average. And with respect to safety rating, I think we are only we are the second worst among all the sectors, next to agriculture and marine sector, if I'm not wrong. Secondly, are we sustainable? Is the current process sustainable? So construction sector accounts for around 39% of carbon dioxide emissions in the world. And in the past research, it has been seen that industrialized construction methods have proven to reduce these greenhouse gases by reducing the waste, reducing equipment usage, improving the reusability of components, etc. So that's my second motivation for this talk, which is industrialized construction. Next, do we have a good coordination and safety first approach? Do we have an effective supply chain? Or do we have a high performing production facility? That means, can we build the buildings at higher productivity with lesser waste every time? There might be some of the outlier projects which are really good in productivity, etc., and those are marketed. But are we having that across the construction sector? And is the construction sector suitable for a high quality product? For instance, we are constructing the projects always in the outdoors, subjected to a lot of weather variations, etc., which might affect the quality of the product. So does construction sector have that potential to actually deliver a high quality product in the best conditions possible? These are some of the questions that we need to think in the back of our mind when we are thinking about why we need industrialized construction. Now, looking at the statistics, so this is a graph taken out of the McKinsey Global report from 2017. You could see there are 3 productivities lines here. The first one is on the manufacturing from 1995 all the way to 2040. What you could see is like the productivity in the manufacturing sector has almost doubled. And as an industry average or a total economy, there's again around like 50 to 60% improvement from what we have seen in 1995. Whereas in the construction sector, we just have it from 100 to something around like 102 or 103, that kind of a thing. So we have not improved at all, given the improvements in technology, given the improvement in robotics, given the improvement in a lot of other sectors that is supporting construction. I try to see this as an opportunity rather than a challenge, because what can we do to improve this productivity? And in the same report, they have actually looked at different countries marked on their kind of like construction labor productivity improvement. And we have India then as an accelerator. So that is why I was thinking of giving this talk at this particular point, because we as a country are in the accelerator phase, but we are not in the outperforming phase. So if you could take India from here to here, that is where the most of the impact is coming in. And you would always know that India is one of those countries where there is a lot of infrastructure being constructed when compared to other countries. If you're seeing UK, there would be 1 or 2 mega projects at the time that we are speaking now, which is High Speed 2 and probably Crossrail, which is already delayed, and the Tideway. Whereas in India, you could see a lot of metro construction projects, a lot of large projects coming in, and there's a lot of residential kind of like small projects being constructed. So if you could actually transform our construction from this kind of like a little bit of like underperforming to outperformer, we would have like really good impact within us. So the reasons for industrializing construction is poor productivity, the low quality, complex production environment. We are dealing with a lot of stakeholders, dealing with a lot of subcontractors, a lot of fragmentation in terms of design, construction, and operation. Within the design itself, there is multiple teams like the architecture, structural design, MEP, etc. And generally, construction is seen as a low profitability with margins of really less profit, and that is also causing the decline in productivity because there's not enough money to put into research and development. Further, we are seeing a decreasing workforce. This is in global terms. In India, things might be a little different, but on the whole, you could see a decreasing like workforce in the construction sector, and we are going to have like huge global housing crisis with people moving into urban areas more and more every year. Further, the last but not the least is lack of available materials. So we've been exploiting the nature a lot for construction, and what we have seen is like we are losing the materials and we are causing a great deal of greenhouse gas emissions. Most of the carbon footprint is from the embodied energy in the materials, so we are not reusing materials enough in construction. And there's a whole movement in the construction sector towards a circular economy, wherein all the materials that are being used should be in one or the other way recycled and put in new buildings. So what we do is like we are removing the footprint of that embodied carbon. So we're effectively reducing the. I'm hearing somebody. I'm trying to Senthil, where do I find the icon to mute everyone?
Sir, I already muted, so you can continue.
Okay. All right. Thank you. So what I was talking about is there is a movement for in terms of like reusing the materials in construction, and that's in most of the universities are researching on it in terms of circular economy. And I'm aware that IIT Madras in India has a new center on lean and better materials using lean technologies, and they are also looking at the circular economy if you are interested in looking at the sources within India. So these are the reasons that we are going to industrialize construction. So I have seen that some of you have already put in some of the answers. So my question now is like, how is traditional construction different from manufacturing? So we are talking about industrializing construction, but first we need to know like why traditional construction is different from manufacturing and what are the problems with it. So if you could go on to menti.com, use this code and put in some of the answers into it, and I will wait like around 1 minute for that, and then we will continue the discussion. So obviously, like some of the answers have already come up. The traditional construction is more customizable. That is true. 90% of activities are on-site and labor-oriented, more tolerant. So should we continue with that? Main difference is in quantity. I'm not sure whether that might be a correct comparison, because if you're looking at mass manufacturing, the quantity is high. I think what might be the difference is the scale of a single product, because what you're seeing is like the buildings or anything that we are doing, it is like really huge when compared to the mass manufactured things. Precision of the work is more accurate in manufacturing, true. Unorganized labor, casting of components on site, project site locations are changing. That's again true. Manufacturing is done in a controlled environment. Yeah, these are all really good answers that you have put in these question, and I will wait for another like 15 seconds or so before moving on. So my question here is, do you think manufacturing was any different before all this mass production came in? So we are looking at more customization, more activities on site with custom tools and stuff like that. We are looking at quantity. We are looking at the kind of like controlled environment. Manufacturing will be difficult if the changes are made by client. That I think we'll be dealing with that question a bit later on. But that is true again. Like we are facing a lot of change orders in the construction sector. So these are really good answers, which takes us to the next part of the presentation, which is on can industrialized construction help while retaining all the positives of traditional construction, but eliminating all the negatives. For that, we need to think a little about the manufacturing paradigms. So when we talk about manufacturing, we always think about the manufacturing that is now, which is what we have seen in some of the comparisons in the last slide. But what I would like to know is about craft production in the start. So these was manufacturing before the assembly lines. So it was all kind of a matter of highly skilled workforce, and artisans were the source of pride, that they really were of pride of manufacturing or creating that particular component. Just think about Rolex watches or like Rolls Royces, where they do everything in like with hand, and they have a source of pride in that craftsmanship. And one of the things is like they don't use specialized tools, they use general purpose tools. So it's like a common toolkit for everything. Whereas in mass customization, it's like specific tool for everything. The final product is mostly unique and it's catered to the client's needs. And it requires a long process of custom fitting. That means like you're doing everything in a custom fashion, just like what you were telling earlier, that in construction, everything is customized. Similarly, during the early phases of manufacturing or in the production, during the craft production stage, everything was custom fitted. And basically the organizations were fragmented. There were people doing, there might be a lathe, which is doing really specific tasks about the lathe, and there would be somebody who's doing foundry, which is different. And they have like kind of like highly skilled forces for everything, workforces for every particular small task, but it's not integrated. It's all fragmented. So this craft production is, if you compare to craft production to what we see as traditional construction now, there are a lot of parallels to it in terms of like general purpose tools, a unique final product, long process of custom fitting, fragmented nature, everything that we have talked about in the previous section of the presentation. So what changed manufacturing was this idea about like mass production, where they were creating like a standard product for everyone. And I would like to like show this quote from Henry Ford from his book, My Life and My Work. What he's told is like, any customer can have a car painted in any color that he wants, as long as it is black. That means you're not doing any customization. So you're just thinking about throughput in the manufacturing, that like produce maximum amount of commodity at the lowest price, so that you could deliver it to the customer with the highest value. But the thing is like you lack the element of like customization there. So this was what production or manufacturing changed from like craft production first into mass production. But the thing is that it didn't stop there. So I just want to know your opinion on why did mass production succeed? So you can, if you look at that Mentimeter, you could have like, you could enter like three words onto it. So we'll see like why you think mass production succeeded. I'm assuming you all could get into the Mentimeter. I'll wait around a minute. You might have to refresh your Mentimeter page for this question to load. Okay, we're getting answers now. So that's assembly line, sustainable, cheaper quality, lesser wastage. So why did mass production achieve these things? End result, economical, quality, good. It's fast, definitely it is fast. So how did it make it fast? More profit, repetitive, true. Any more? Are we seeing any more coming in? I think all of these are really good answers in terms of why did mass production succeed. So better quality control, huge quantity can be produced. Yes, great. These are really good answers, and I mean all are correct answers in a way. So there was a study by Womack and John in 1990 studying exactly this idea. Why did mass production succeed? So assembly line is one of the main factors. Higher numbers that we can produce is good factor. But what came down to as really good success factors was interchangeability. So when there is problem within the production line, they need not stop the line. They could interchange it with a likable component. Then it is like simplicity in assembly. So it's not too complex to assemble. So you don't need a really high specialist for every assembly. The third was ease of attachment. And this is what helped to actually build the product faster. And even if there are problems with the line, you could just change it with other parts and it would get into the into the product really fast. So all of these three things is what made assembly lines and mass production a success. And if you look at some of these things, we could see that we could bring customization into the picture because there are interchangeable components. The attachments are easy and there is a simplicity in the whole process itself. So that's what was done later in the manufacturing, especially with the Toyota production system. So what they tried is to remove errors from the system. They were improving the flow of the construction process with just-in-time kind of construction, so less inventory. Most of the kind of like processes were standardized. There was stability in the production line. This led to highest quality, lowest cost, and shortest lead time. So all of this, we are looking at it from a kind of an automotive sector. But what we have seen is like automotive sector in the era of craft production was just like construction, what we are seeing now. But they've improved over the years. And that's why kind of like the productivity curve and the productivity of the sector has doubled in the last 25 years. Now, still, we have not achieved mass customization. It is like better products coming out of the automotive sector. That's where we brought in lean construction again. There, what happens is like you can have higher variety of the products. A lot of automation came in, lesser labor, lesser inventory, and lesser rework. So we have high volume production. Also, there was like higher variety. Because the parts can be interchanged, there were better kind of like production variety coming. So it is not like if you want a color in a car, that should be black. That was Henry Ford's idea. Now you could bring in like more colors, more customization, better interiors, better kind of like change of tires, etc. So all of those came in with progressiveness and the lean production within the Toyota production system. Then came the newer idea about customization. So that is when there was a little bit of idea about standardization of the parts, and there was like interchangeable parts coming in. So the customer could place an order of a particular type of a customized car, which would be in the platform of a big car. Maybe let's take the case of like a particular Toyota, let's say a Toyota Innova, for instance, ones which we are seeing. So we could order it in a particular color. We could order with a particular engine size. We could order it in diesel or what do you say, petrol. We could order it as automatic or manual transmission. We could have higher quality interiors or low quality interiors in it, like leather or other one. We could have different colors. We could have accessories on it. And all of this goes as into the same kind of a production process. And you come out with that customized car. We still know that it is not as customized as a building that we have. But the thing is, like, this particular production philosophy could deliver highly customized products at cost comparable to mass production. So the customer is not losing a lot of value on customization with kind of like standardization of parts, because he's finally getting a kind of a unique car. It's not as unique as the building that, or as unique as a car you might get in a craft production, but still it's a highly customized product. So if you look at it, how manufacturing has moved, it is from craft production to mass production, then to lean production, then to agile production. But in the kind of like house building or the construction, we are still at this particular phase. Now, a second comparison, because automotive sector, the product is really small. We're just thinking like, is construction different? So let us take the case of an airline in which a big kind of like a structure is being manufactured in a production facility. So the assembly line is not actually moving because it's all assembled. Like people are coming into where we are doing the assembly. All of those things are coming in the aircraft sector. So, and they have also adopted this idea about agile production. And what we have seen in the kind of like airline sector is like there are around 6 million parts in an A380 that's being manufactured, which is coming from all around the world, manufactured at different places and which is being assembled. So can we take the same question to kind of a building? So how many parts do you think are there in a building which is around like 7 floors tall, 420 rooms, 40,000 square feet, residential or like a hotel building? So just go to menti.com and you could key in the answer. So we're looking at, there's one answer on 1 billion, 10,000 to 100,000, 100,000 to 1 million, more people towards 100,000 to 1 million parts. There's no correct answer again, I'm telling. I'm just getting like a perception. Okay, more on that 100,000 to 1 million kind of phase. Okay, let's move on. So you've told, some of you have told your idea about like how many parts are there in a building. So how do you define a part then? Just your perspective. Again, there is no correct answer to it. I'm just getting like an idea about like why you chose a particular answer. Monica Srivastava has her hands up. Does she has any question? Please unmute and. I'm unable to see the Zoom screen on this on my computer. That's why I'm just asking you to unmute and probably ask a question.
Yes,
Hi.
I already said to her to unmute, but I think so now. No, I'm not able to see her hand, so the query is resolved.
Okay, great. Yeah. So basically, components, slab, beam, column, divided spaces, one single piece of construction like a brick. I think all of those are true. So we could think about it in different ways. So if you're looking at a column, is a column a single piece or is the rebar inside that a part? So a lot of things are ambiguous in kind of like the questions like that. So if you look at, we could be like, is it an object installed as one piece? Is it at logic level, which a piece of design or object is irreducible and unique, just like a rebar, for instance, or is it a combination of systems that work together to provide a function, like somebody had told about divided spaces and previously. So these are all true answers. But what we have seen is, like, in our sector, we don't have a uniform definition for a part. So that's kind of the takeaway. Whereas in the manufacturing or in the kind of automotive or per se like airline, aeronautical, they do have a definition for part. And that's, once we have a definition of part, we could think about that part as a point. There might be interfaces with other parts. Then we could see like how they could connect together, how it could be interchanged, etc. So we don't have that idea about a part in the construction sector at the moment. Now, with that, you might have got an idea about traditional construction sector, why we should industrialize construction, and some of the manufacturing paradigms. Now we go to industrialized construction. So the question is industrialized construction just prefabrication, that you are prefabricating the building components at some place and then building it on site? And will prefabrication alone help? So prefabrication has been around for a lot of time in the construction sector, but we have not literally moved on beyond prefabrication and thinking of it as the whole process. So if it was just prefabrication, a mass customization would not have worked, like, because you need to have a process to bring in all the information for the customized product together, and there should be a workflow to do the customization, and still that workflow should fit inside the production process to get the things delivered. So there was an idea about this industrialized housing, which later came out to industrialized construction, which was done by a researcher at Stanford called Jekyll Luzins, and his idea is around the six parts kind of idea about industrialized construction, and the seventh part on continuous improvements. Yeah, so the first thing in industrialized construction is we need to have technical systems. So technical systems are basically essentially the parts that could actually be interchanged, which could be connected with different sets of things. For instance, think of a washing machine. It is a part in itself, right? But it has interfaces. It needs to connect to the right power supply. It needs to connect to the water supply. It needs to connect to the drainage. But the part itself is, there are like, you have like different kinds of parts, but all you need to standardize is maybe the size of the washing machine, if it has to go into a cupboard or something like in the kitchen. The power supplies should be standardized, and kind of like the water drainage and water supply should be standardized. And if you look at the kitchen per se, where the washing machine is being put, that kitchen should have a provision for all of these connections to happen, and kind of like a place for this washing machine to go in. So the washing machine is a technical system, the kitchen is a technical system, and these two technical systems will work together. So that's the first thing that we need in industrialized construction. So if you manufacture like hundreds of kitchens which have this property and hundreds of different kinds of washing machines which has this interfaces, they will always work together. The second thing that we need is prefabrication. So how do we manufacture these components? So these should be manufactured offsite because we have better conditions to control the quality. It can be manufactured in in kind of like an area where there are no risk of falling off heights, etc. You could have like specialized tools, so it makes the manufacturing faster. Then there is the idea about long-term relations. So whenever you're thinking about manufacturing, you would have suppliers, you would have like vendors, you would have like teams who are actually interacting with them. So they have like a long-term relation. So I think that part is kind of sorted in construction per se, because a particular contractor would always have like a long-standing relation with subcontractors, etc. But I think that is important even more in industrialized construction, because if you want to change a kind of a supplier or a vendor, then we need to retrain the new vendor to the systems that we have. We need to have like logistics properly. So we need to understand like what part has to be manufactured within the correct time. So we had a project in which uh, um, there was a manufacturing facility which was manufacturing bathroom ports, corridors, MEP systems, etc. So for the manufacturing facility, the best part of manufacturing is like if they could manufacture like 100 bathroom ports in a day. Whereas for construction, you can't like accommodate 100 bathroom ports in a day because it's manufactured in a different, I mean, like it's constructed like floor by floor. So you only need so much of bathroom ports in a week. But for them, the incentive was different. So you need to come about with a logistics plan for the manufacturing as well as for construction so that there is a better idea about how it is used. The next one is about use of ICT, so information and communication technology. So we earlier we talked about different systems and them fitting together. So let's say you have like thousands of systems. How do we know that it fits together? So to check that, we need an ICT tool. So once it is fit together, how do we inform the manufacturers to manufacture the thing within a particular set of times? For that, we need ICT tools. And when it is being manufactured and delivered, we need to track all those details. For that, again, we need ICT tools. And there's a lot of like use for ICT in there. And once we have all this, so one of the things I missed out is the planning and control of process. So we also need to think about how these things are planned out and how the production is controlled. So it's not like one building alone. We're thinking about this planning and production as a process platform where it could be reapplied into every project. So every project would have like a standard set of processes that we could do. And then that could be transferred, and you might be learning something from one process that could go on to the next thing and then to the next, etc. So whenever that is happening, we could reuse the experience from a previous project onto a new one. And it's not just transferred along somebody who's working in the project, it's also along the process itself. The process gets improved. So it's a company-wide transfer. Then we have a customer and market focus. So that's basic because we are the values for the customer. So we should think like what they want and develop the systems and processes around it. And finally, continuous improvement. All of these things should be systematically improved. So coming to kind of like industrialist constructions first view, initially what people were thinking was like they would have like a standard structure where all this kind of like manufactured components would go in. This was first seen in Japan, and that was the first view. Then when the kind of like customization came, what happened is like people design a building as a traditional construction. Then there were split designers who was splitting that design into different prefabricated components and then led to the factory. And there was assembly technician who were thinking about bringing it together. So what happens is like the first part of the thing here is just like traditional construction, and this was going on to the other one. But over the years, what we found out was this was not really effective. Now what's happening in industrialist construction is the idea about platform. So just like what we have told earlier about in the industrialist construction, you will have a lot of components like that could be of different things. And it could be manufactured by different people, but there's a little bit of standardization on how those components connect with each other. And then that would define like standardized interfaces. There is standardized manufacturing and assembly processes. Then all of these things would be like sub-assembly. So the components, if you look at it, if you take out the building, it would be like this. Then it would be turned into sub-assemblies, and there would be connections, which is bringing it all together. And we finally get a unique building. So if you look at it, we are manufacturing a building, yet we are getting a customized solution. But for this to work, we need to have standard manufacturing procedures. We need to know whether all components are, interacting with each other properly, and is there whether they would fit together in the construction site, whether the assembly can happen, etc. So this has led to the thinking a lot more onto off-site construction. There's a lot of automation with a lot of the things to actually mark the precise points where this would be placed. There's a lot of machine integrated variables, because when we start about thinking about these components which are assemblies coming in, it is going to be really heavy. So you need to help people actually work on this. So this is where I talked about specialized tools for the manufacturing. So when you have like exactly the kind of like exoskeletons and kind of a load bearing mechanism, we can actually construct it really fast without injury to the worker, etc. There's like a lot of things like 3D printing when it comes to like really customized parts. There's like single task robots, which does that particular thing. For example, if you want to create like drilling points, etc., you could use these kind of projects. So all of these things, if you're looking, it's a standardized process. The standardized process on particular task, which is going really fast, unlike the construction where we use general purpose tools to do like tasks, and we use the same tools again and again, but it's not the ideal tools reducing the productivity. Now, that takes us to the idea about projects, process, and platforms. So we talked about industrial construction, we talked about manufacturing paradigms and why we should industrialize. Now we would be talking about how would we achieve it. So first of all, we start with the idea about the projects. So we have seen that the projects are unique, exist only once. It's a series of activity with a certain number of resources allocated, and it has like defined start and end points, and project would have different stages. I just took this out of a REBA plan of work with strategic definition, preparation, concept define, spatial coordination, etc. So that's what a project is. So that's how traditional construction is being carried out. So how can industrialized construction fit in? That's where first the idea about processes come in. So in process,
Sir, can you please unmute your mic? Sir, can you please unmute yourself? No, sir, you are muted. Yes, sir.
now it is unmuted. So
yes, sir.
do you know where you lost me? Which slide was that? Where I got muted?
So this slide.
This slide. Okay. All right. Great. So we are talking about processes. So when we think about a project, we could think of a project as a series of processes that could be repeated. So, and these processes are what are like common between different projects. So in a process, what we have is like we have continuous flow of activities, use information and resources just like projects, but it's continuous. Then it doesn't really have a clear start and end point like a project, because the process, it happens sometimes, it's repetitive, it goes on, etc. And finally, what we need is a platform. So platform could be talked about as a set of common components, modules, or parts that form a common structure. So from which unique products can be developed. So multiple products can be built from the same framework. The easiest example that I could give is of Legos. So you could see like Legos, it has a common structure, common interface. So basically most of the heights would be standardized. The interfaces are standardized because all of these, connections has equal spacing. So even though there are like different components here, different shapes, etc., it can fit in together to create a unique structure. So if you look at it, this is kind of like a photo from a Lego world. So a kind of like a small street is manufactured from similar kind of components using the similar process, which is like pressing these two together, and you are coming out with a unique project. And the same Lego can be used to manufacture something like a car. Only difference is like between these two, there would be some of the unique parts, but some unique parts are there, but most of the major share of the parts are common. So those are the components which could be brought together to produce unique parts. So can we do that with construction? First of all, have somebody else done it. So this is the Volkswagen MQB platform. So only thing that was useful in an MQB platform, I mean, that is common in an MQB platform, is around this area. So that particular area is the most important in terms of ride and handling and safety, etc. So they put billions of dollars researching on to develop that technical system, which is the MQB platform. Then they created many cars from that particular platform. So all of this from year to year is variable, from year to year is variable, etc. So starting from this particular center of gravity point towards the A pillar is what is the platform. And there's like different cars, like Seat Leon is on this platform, Skoda Octavia is on that platform, Volkswagen Golf is on that platform, Jetta is on that platform. I think Audi A3 or A4 is on the same platform. And similarly, the platforms has been used in different things. For cars, if you look at shipping container, this shape of the shipping container and the anchor points was standardized. Just because of that standardizing, the whole of shipping process became easier. Most of the ships has the same kind of stacking. The ports has the same kind of lifting things. So the process could remain the same across the country, across the languages, across times. And this has been there for a long while. Similarly, in software system, there's like App Store platform. Like if you have an Android, you have like a Play Store, or iPhone, you have an App Store, and all of the applications can work on a certain things. Like they need to come about in a particular screen ratio. These are the interfaces. This is how you connect to internet. So those protocols remain the same, but the application itself is different. So there's like customization in application, whereas there's a kind of like idea of standardization in the processes on how we deliver that. So the platform has worked in a lot of places. So that is the idea about platforms. And think about platforms with a common process, and the process is like different, and it all comes together into form a project. So just like the previous thing, think about it again. You have like components, you have interfaces, etc. You have a set of process to assemble it, manufacture it, etc. You have a process to design it. All of those remain the same throughout the projects. The products are manufactured, so it is of high quality. Interfaces are defined. Then you could come about with unique projects, unique construction projects without sacrificing quality or productivity or safety. Now, what is the advantage? So the traditional construction is around here, which is like bespoke solution or like one at a time solution, a simple process, which has like low productivity and low manufacturability, whereas there's like a volumetric things with standard solution and standard process. Here, the uniqueness is not there. Then there is like components or something where it's unique, but then it's not mass manufactured. Then there are manufactured platforms where it's bespoke solution that we are getting a unique building using standard process and standard components. So it has better efficiency and it increases efficiency and effectiveness. So what we need in the construction site, in a construction sector to do this. So we need to have a set of systems and subsystems and interfaces with standard components and standard interfaces and standard design and rules. And we need to have a process platform which kinds of looks at combining this technical system into repeatable process across the projects to deliver custom products. So that's what we need to think about. And how can digital help it? That's what we will be discussing in the next section. So basically we have a standardized set of components, and every project will have a set of components from this, a subset from this with required numbers, etc., which is just like a Lego kit, but think about it as like a bill of quantities or something, and it delivers unique projects. So that's what we are doing. There are like components. It all comes together as a sub-assembly. Then it comes together as a unique facility. And it could be residential, manufacturing, or anything. And the idea is like when you're creating a technical system or something, we have like ideas about it going downstream. So if you are creating a particular thing about a particular dimension, we need to think about how it would be configured. how it would be manufactured, and how it would be assembled. And there's also idea about rules and restraints going up. So a machine can only manufacture something about a particular dimension. A customer requirement was like this, it will be broken down into small pieces like this. And if it has to be lifted or something, all of those ideas would be transferred back into the configuration part. So there's information from the design of the customer, and there's also rules and restraints from manufacturing and assembly processes coming back. And that's how we could achieve this particular idea about development of technical system. What is good about this? First, let's say we have a version 1 of process and technical subsystem platform. We do a project X1, and we learn a lot of things that some of it is not effective. And by the time a project X2 will also be starting, all of this uses the version 1.0 of the technical subsystem and process system. But as we finish this process here, and there is another project Y which is starting, and we have got some learnings from it, we could start with the version 2.0, learning from this project 1, and start that project with a better product. And there might be some projects which are still using version 1, but we could improve it with 1 or 2 or 3 projects. And when this is like repeated among like multiple projects over the years, we are improving the productivity, we are improving the system, we are getting a better product at the end. So it's kind of like, just like think about iPhone 1, iPhone 2, 3, and over the years, it has improved based on their manufacturing problems, based on user feedback, based on the technologies that is developing around. So we're not going to go with the oldest technology now. So there was a case with Crossrail, when the Crossrail is a major underground construction metro rail kind of a project in UK. So when Crossrail was envisioned in 2005, there was not iPhone, but Crossrail is not delivered even now. Now we have like the 10th version of iPhone. So what they did is like over the course of the Crossrail construction, the process has changed in which that people have iPads on the side to report construction process, etc. So we are having a little bit of those improvement coming in the process, but not much in the technical platforms, etc. So that is a major benefit of industrial construction, because we are continuously improving. Now going on to almost the last part of the presentation, which is around digital configurators. So our ideas, like we now know that there is a customized product that we need, there is platforms and components that comes together, and there are processes to deliver it. But how do we achieve it? So that's where digital comes in. So customers would be able to customize their product within a certain kind of limitation, of course, and that would be transferred into kind of like a manufacturing to deliver it. So examples, you could see it out there. So in a Nike shoes, you could actually customize the colors. If you are ordering a computer, you could customize the kind of like components inside that computer, how much RAM you need, what processor you need, within a certain number of specification. In cars, you could do that in terms of like engine, colors, transmission, kind of like trims, etc. And more importantly, if you're looking at like IKEA kind of a setup, you could actually manufacture a wardrobe from a lot of like components that are already available, and the system checks whether that could be manufactured or not. So that's what we are looking at in digital configurators. So customer would have like a particular idea about the product. It would have like a solution space with different components, and each of those are manufactured and taken together and then. So can we have, or are there many kind of like components like these in digital construction space? So there has been a lot of studies on configurators and digital space in construction, and this is one of the latest study. So the idea is like there's a user inputs, there's a configuration of rules, then there is like a product structure which is called a kit of parts, which is a lot of parts which could fit together. So when we have both of these, then we could come to a customized product. There are like different typologies of that. First one is a planning configurator, how we plan kind of a building in a particular space. And there is this wonderful app by Bryden Wood and London government. And I'm just see, it's called prismapp.io. So if you go in here, you could actually create this app, like create a building in less a minute. So it's based on London. So you put in the postcode of the London, you get the buildings around it. Then you could choose a particular site where your building is to be manufactured, developed, and you could mark that area. Then once we have that area, you could choose like type of the building, etc., the building configurations, and like type of the things like outline of the buildings can be coming out here. Then you could even go into sectioning the rooms on what kind of rooms, etc. And it all comes into a kind of like something like a intelligent building information model at the end, which is both parametric and we could run simulations on it. We could run like, analysis on it, like how many commercial spaces, how many other ones is required, how many customized things is required, how many like manufactured ones are required. Then what is kind of like, what do you say, area of the building, you could think about configurations, all of this from standard set of components so that it could be manufactured. And this might go into like, finally what happens is like you might get a fully written report on all the specification, total height, which you could submit to planning authority. And it can all happen within a matter of like 1 or 2 hours instead of weeks. So that is kind of like a planning configurator. Second one is a design configurator. So if you have a plan, what components that you have to use, etc. So this is there's a company called Project Frog, wherein what they have is like parts library, interfaces. Then there is an automation engine where we could look at whether things would be fitting together, etc. And then it can be taken to manufacturing. Finally, you have like production configurator, which takes in this idea from these the type 2 kind of configurators and manufactures it. So this is one of the company which does 3D printing just like that. So you have what do you say, something like a CNC machine. You have a model that takes in from the type 2 product configurator and it goes into the production. It prints the structure. Similarly, there are like CNC machines for manufacturing timber panels, etc. in the space. Now, one of the problems that we face is like these 3 configurators are like fragmented, but now people are coming up with cross-face configurators, which has like starting with the layout and stuff into kind of looking at the building length and building components, and then all the way to production, all in one tool. So we could actually create, and this looks at from a set of already available manufacturable parts with all the interfaces. So you are doing the whole bit of design within a day or 2. And there's a particular project going on in Switzerland called 7-Day House, in which they start with a concept on day 1 of a week, finishes the design by first week, constructs, delivers, and hands over on the 7th day, kind of like a customized solution within 7 days. So those are the kind of like cross-face configurators, and you could all do simulations, etc., to understand energy, how much it is, producing lighting, how much of daylight is used. All of those simulation can be done because we are producing an intelligent model at the start. We could put a sunlight path on this and understand what's the lighting inside. We could look at the ambient temperature and how we can optimize it with materials. All of these things could be calculated, and simulation can be run within a short time with these kind of digital configurators. Once it is manufactured, we could also track the deliveries and stuff for planning, and that there are already research on digital tools for that available, which is integrated with Navisworks Manage. So with that, I come to the conclusion of this presentation. So what we are getting is increased efficiency, faster delivery, better quality production, sustainable construction, and continuous improvement with industrialized construction. There's a little bit of losing of customizability to a particular extent, But still, from the Lego example, we could see like with enough technical systems and interfaces available, we could come up with unique projects or unique structures within the idea about what do you say, faster delivery times and better productivity, which is lacking currently in construction sector. For that, we need standardization, interoperable platform development, long-term supply chain relation, and more than everything, a change in mindset. With that, I conclude my presentation, and I think I'm good with time and open for questions.
Yes, Ranjit, this Senthil, again, thank you. It's very informative. And I have got one question. Countries like India, with the limited logistic, infrastructure, how suitable this modular construction is going to be? Will it increase the time taken to, one of the advantage that we claim is it'll reduce the time, right? I mean, the components are going to be assembled at site, and then it is going to be this thing. But suppose if we make many smaller ones to accommodate the logistical challenges, even transporting a truck of a fly ash to our site is difficult for us. We are not away from the town. Still, so I mean, how best that these things are going to be in India if we introduce it?
Yeah, so first of all, I would like to contrast it with two places which I've experienced, and then I will come to the question particularly about India. So the first one is in UK. So there was a lot of research on to where to place these factories by the contractors themselves, like large contractors, to see how to best provide within a short amount of time to this. So they combined both what you say, road, rail, and water transport for that. And that itself is kind of like a research question when we are developing the infrastructure. Second was in Singapore. So Singapore, how congested it is instead. So they were manufacturing it in different places in Malaysia, Thailand, Indonesia, and they were doing this cross country to deliver the products. So my idea about it is around like, and both of these things they learned from the manufacturing sector, especially from aeronautical sector, where some parts of the Boeing or Airbus is manufactured from around the world. These large components transported and assembled at one particular factory and then flew off from there. So they learned from that. So in India, what we need to do is kind of think of this different hubs. So it might not be like one hub for whole of India, but it would be like a different set of hubs, and that hubs should be located close to a transportation facility. And something that we should be proud of is our railway network, which is really good. So if it is close to railway network, has kind of like association. So this is something that comes at a policy level on improving construction. So, and then partnering up with the logistics teams to bring it on. And when we are actually manufacturing the components itself, you might have seen like it has restrictions on the size, etc., based on the transport opportunity. So we are optimizing the design in terms of these components. And in UK, there are like sub-assembly spaces. So they come in and there's like sub-assembly factories, which does the sub-assemblies and taken into construction site. Especially within London construction sites, it's very congested. So you can't do any assembly in the sun. So they come in as like small packages and it gets lifted up. So the same in Singapore. So I've been to both manufacturing and assembly facilities, as well as construction site in UK and Singapore. So everywhere it's kind of following that model of manufacturing it, coming it as a sub-assembly. So the idea is like these things, only thing that you need in the construction site is like proper kinds of cranes to lift it up and place it, and some kind of like a skill set on that one. So it comes in, and when you bring in the principles of just in time, etc., into the picture, I don't think there would be a big problem in delivery. The problem is when we don't have that long-standing relationship with suppliers of logistics teams, so you can't predict their performance. So if it is like every second construction, you have a different logistics team coming in, then you can't have all the facility. But if you have something like this, for instance, Amazon works in India. So Amazon or Flipkart, if they could do next day delivery in India, that's because they have thought about the logistics and how to partner up with different kind of providers to make the thing reach it on the next day. Similarly, we need to think about in that format. And I think the logistics is a challenge, but it's not a challenge that we cannot overcome.
Yeah, we have some question in the chat box as well. I'm not
wrong. So can you read it out for me, or let me find the chat?
Have you explored the disadvantages of this system? So far, the presentation has talked or looked into only the positive aspects. This is from Mr. Samir Ali Abbas.
Yes. So basically, we have done that particular thing. So we have partnered within the UK. We have partnered with one of the leading contractor here to look at this particular thing. And some of the disadvantages that this came is about some things cannot be custom made. For instance, when they were doing the Crossrail, they couldn't manufacture something. The second thing is bringing this whole thing down into the tunnel. So Crossrail was a lot down. So they had to re-engineer the whole process to make sure that the big components are taken down to the tunnel, taken into the position, and literally every turn which is more than 30 degree was programmed in. So that planning phase was a really big challenge in such kind of a project. So residential sector, we haven't faced much a problem here. But in infrastructure, such as this metro rail construction, there were a lot of problems like that. So we had to bring it down. So we used augmented reality to kind of check whether the whole thing would go down and there won't be any hitting where we need to change it. So some of these things have to change. And some of the custom, just like launching girders and stuff, we had to create a lot of machines for this infrastructure project to bring in this thing and assemble it, because these are heavy load machines which cannot be taken in trucks underneath. So we had to have like track and trolley systems developed, especially for assembling it. But with that pain in mind, what was seen as there were $1 million savings in Crossrail just because of this process. There were like time crunches in Crossrail because of this, because Crossrail started getting delayed at a point and they wanted to, I mean, it's still delayed, but the kind of like delay was reduced just because of using this process. If that answers your question.
Any other questions? Okay, right. If there are no questions, then I would like to thank Dr. Ranjit, and it was very informative, and it is a new insight and a new direction that the government has to look at it, and then come up with policy changes, as you said, to enable this kind of technology to be practiced, and then make some savings out of it. Yeah, thank you so much, and I hope we will be associated, forever. And great.
Yeah, thank you, Senthil, for inviting me for this particular session, and I thank everyone who has listened for their time. Thank you very much, and try to kind of like keep this in the mindset when you're doing next projects or educating the next generation of engineers in India.
Yeah, that's great.
Yeah,
good.
Bye-bye.
Now, a small housekeeping kind of announcements. Like tomorrow, there will be 3 sessions, and followed by a valedictory session, and there will be an assessment also in between. Like we have an afternoon session from starting from 2. So I would like to make it at 1:30 instead of 2, so that we can get some amount of time to do an assessment. Assessment is going to be mostly 20 questions, multiple choice, which will be there in the Google platform, Google Forms. So you have to answer. It's very conceptual, understanding level questions. Not you don't need to prepare anything. If you are attentive in this meetings, then I'm sure that you could be able to easily answer all those questions. So that's a part of a custom which is required from ACT for you to get this certificate. So please, without fail, attend this the assessment. And If you face any other things, please let us know. We will be there. Our IT team is there. Our assistants are there. Mr. Nikunj and Ms. Anju is there. So you can talk to them. You can write to them. Get whatever you want. I hope they'll start giving you access to all the videos and other things, the recorded videos. Yeah. If possible, I'll compile all this presentations and then send it to you or upload it in the ACT website. Later on, you can access to it. Thank you. Thank you. Thank you. We are ending for today. Thank you so much.